There's an interesting company that's building a autonomously reconfigurable manufacturing line. So basically, the conveyor belts are all on mobile robots, and you can hit a button and the whole factory reconfigures. So they can go from building one thing and hit a button and essentially go to something else. Not quite as simple as that, but it is an interesting concept. And then finally, we're seeing the more rapid adoption of different kinds of delivery methods. We're certainly not there yet, but we've heard about drone delivery packages. FedEx Express did their first delivery this, actually, I think it was the end of last year in Virginia, where they used a drone to do a package delivery. We're seeing the last mile. FedEx and Amazon and others are also looking at that. And then, as I mentioned, more robots within the workplace to create a safer workplace. What does this all mean? Obviously, a larger increase in deployment of robots, but more interesting, a larger increase in robot and human interaction. These robots will be in our environments. They will be on the factory floors. They'll be on the sidewalks. And this means that humans will have to interact with these. And that means that they have to be safe. So I'm really excited to be here and hear the discussions. As Ulrich mentioned, we met last year for the first of this. We're continuing to see growth and interest in cybersecurity. I think there needs to be a lot more work done. So I'm excited to hear from the speakers today and learn what is actually being done in the trenches to address these issues. Ulrich, thanks a lot.
Thank you very much, Tom. That was a very interesting insight on how, on your side of the pond, in this case, the industry is developing, how also the pickup rate, thanks in this case to COVID, is happening. So good to see that people are innovating and that basically the industry hasn't stopped. On the contrary, I would say. So very insightful, very interesting to see. So let's maybe switch now for some time to Europe. And Reinhard, I've noticed that you're around. So good afternoon in your case.
Thank you so much, Ulrich. Thank you for having me invited to this inspiring conference. And as agreed before, I have also a short presentation. If possible, I would share it myself because I just adapted it a little bit because there are some elements which might be relevant to this as well, to address also the things that Tom just mentioned. So let me just see whether it works.
So in Boston it was snowing, Reinhard. How is it? How is the weather where you're at?
I'm in Bavaria at home, working from home like most of you do nowadays, and the weather is quite nice, although in an hour it will get dark.
Yes, but no snow there today.
No, not yet. Only on the mountains, but not here directly where I live.
There's no skiing anyway, so that's okay. So
exactly.
You go ahead and let us know how you experienced how in Europe over the last year robotics has been developing.
Okay, I think it was also, I can only echo what Tom already said in many things, but I would also like to focus a bit on a few things and addressing the areas you mentioned. We had prioritized application areas which are mainly bound to a European partnership, which is running until the end of 2020. And there will be a follow-up. I come to this a bit later. But we also saw a couple of areas which are really ready to be transformed. And already almost 5 years ago, we decided to have healthcare, agri-food, maintenance and inspection, especially for infrastructure, and the agile production of promising ones. Now we have additional areas. For example, construction is becoming more and more prominent. We do have a lot of opportunity in the retail and logistics segment, but here is the areas here were chosen mainly because this would also lead to public investment, or with other words, to funding recommendations given to the European Commission. And therefore, segments which are already arriving on a more mature state, also economically, we saw less need for public investment rather than some areas which are typically public driven, at least in Europe, like the healthcare sector, but also agri-food has a large support from the public side. To do this, we don't have any like Tom mentioned before, any physical space nor any actual robots. We are also a non-profit organization, but an organization of organizations, and we are running also some projects which also relate to different areas. We had some structures which is called digital innovation hubs. I don't want to go in the details here, but these are also publicly funded entities to create the mentioned ecosystems, to create access to research, but also the non-technical aspects such as access to finance, testing, demonstration, piloting, and such alike. And these structures are being put in place in recent years, so it's relatively new, and it will continue over the next years with a slightly different funding. So this is just to mention that where we stand as the association at the moment. From a technical or let's say strategic approach, what we do need is a holistic view. We need to have, for example, here in the image like a drone doing some inspection task, we need not only solid mechatronics, good perception, edge computing to make the first data analysis directly, for example, in a drone or in another robot. We need also cloud services, high performance computing, and all relates again to safety and security here. So this is core, because these machines will in the future not be operated. If they are teleoperated, there is still a risk from the cybersecurity point of view, but also there will be fleets of those things which are not individually operated in the future. At least this is what we are looking at. So I can see the direction where the data, AI, and robotics environments need to be integrated much more. So on the one hand, we have these typical business models. We have a huge discussion about a European framework to put it in, and this resulted in the development of a strategic innovation, research, innovation, and deployment agenda with the collaboration of many stakeholders. We are focusing on the European level, but still we want to be open and inclusive. And also, of course, Europe is open, and it's clear that we can only do something in an international global context and not sticking too much on ourselves. Whereas, for example, funding is clearly located within Europe. What we need to do from the perspective of supporting the ecosystem, we have the areas such as mechatronics, sensing, perception, decision making, also interaction, what was mentioned before already, with the human, but also with the environment, with other technical or non-technical things, which become also more smart and interactive in the future. We have to have all the things that relate to physical platforms, knowledge tools, design tools, components. But one of the key elements to actual take up by the market is trustability. And this requires not only that the machines and the technical side is very well designed, but also that we are living in an environment where we have good regulation and standards, so that the businesses are able to operate within a given legal and standardization framework, so that the actual ecosystem can develop further and quicker. And this requires also validation, benchmarking, testing, certification to reach to the final goal of deployment and uptake. And of course, the final user side needs to define what the use cases are. So what cannot be done is that the research side develops something which is not really taken up. So this is a mutual way forward. Let me quickly present a few numbers from the economic point of view. So I have this slide here with a graph on AI spending by industry, and you can see that a larger share is here in the banking and insurance, but also in the retail and wholesale, whereas for example, discrete manufacturing is already still 12.1%, but it's a lower share, whereas the robotic spending has a vast estimation of the representation of the discrete manufacturing here, we have 35.7% of the robotic spending in this discrete manufacturing environment, whereas sections like retail or others are very, very low. And when you also look, in addition, not only to the classical AI and the robotic side, but also to the data side, then this is a bit more close to what the AI has, but still this is something which will converge at the end. If you look at those numbers in a comparison here, you can see that a lot of things are coming. For example, the construction sector, it's reflected in AI. It's a little bit also reflected in the robotics world. But these are the segments which are likely to grow in the future. And so on the long run, these diagrams will look more similar because we have these kind of integrated systems. And this is one of the reasons why Europe aims to create a partnership, a private side consisting of several organizations, plus the European Commission, to boost competitiveness, social well-being, and so on. You can read it here yourself on the slide. This is what we are aiming at with a new partnership over the next 7 years, starting in 2021. What we did so far is we developed a strategic research, innovation, and deployment agenda, as mentioned before. And one of the elements that are considered, especially here from Europe, is the framework of European fundamental rights, principles, and values, but also capturing the value for the business, society, and the people. And then only when you have this in mind, then you can look deeper, you can look into the enablers. So this means we also need to talk about skills and knowledge development. We need to have fair access to data, and we need also good infrastructures for experimentation and deployment. This would be an enabler for the upcoming ecosystem. Whereas here, this technology side, we leave it up to the experts to deal with the individual innovation streams in certain directions. This slide just reflects basically what I've already said. I don't want to take too much of your time. Here again, the relation between the robotics world, the data world, and on the one hand, and the AI world on the other side. So what we need to see is how a robot connects to the digital physical interaction, where the AI could then come up either with, for example, classifications of objects and environments, interaction with people and objects, but also we are talking about multi-agent systems, and especially here also the cybersecurity aspect is very important, not only in the transmission of data, but also in what could be done if, for example, a robot is hacked and used as a kind of weapon. This is all things to be avoided here. So we all know that the time to market is much longer in an environment where you have to develop a physical hardware than in comparison to, let's say, pure app development. And of course, this goes along with a greater investment and the need for testing zones, but also regulatory frameworks for testing and the operation. And the higher the degree of autonomous is, the more is the need for safety in many use cases. And here also even high-level commands need to be transmitted, and we need to ensure that a robot is not steered from someone who is not ready to do this. So this was basically a short overview of what we are doing currently in the field of e-robotics towards the new ecosystems. And we also see that many things have changed. We will have a new world in a couple of years where the degree of autonomous machines interacting with not only professional users, but also with a lot of private household users and so on will increase. And this emphasizes the need for having very rigid cybersecurity measures in place. So in an industry environment, you're much easier to able to protect your environment and to find intruders. But if you deploy the robots where people are, at home, in hospitals, and so on, then this aspect becomes more and more important. Thanks.
Great. Thank you very much, Reinhard. That was a great insight also from your side. And thanks to both of you addressing cybersecurity so eloquently. It's great to see how both of you are really considering also from your roles the importance of cybersecurity. Now, my first question, Reinhard, is actually to you in this case. And Tom, please join in. And if you have any questions from the audience side, then please challenge them over the chat. The functionality is there, or over the Q&A. So Reinhard, to you, in the discussions that you have with the different EU robotic members, what type of density do you feel that cybersecurity is of importance to them these days? To some extent, you work with the members are people from the industry, are people producing robots. There's also quite a number of research institutes. So how do you feel the debates about this today?
So I think most of the people are fully aware of the need to have it, but they are not experts in developing everything themselves. So this is something where a specific sub-community needs to be created to make the technology available. And making it available means that there are also ideally certain standards and products where you can easily integrate the cybersecurity into your system. But of course, it has to be designed in and not something where you have a classical research prototype which is developed in a university, where you start developing the product in your lab, everything works fine. And as soon as you want to create the startup, you discover that this is an additional need which you did not consider of. This would be the classical approach in many universities, but this is basically not what we want. We want to have these aspects from the beginning on included, and this can only be done once there are systems and tools available that allow for easy integration from the beginning on.
Yeah, I think that's a bit of a challenge to some extent. So now you're challenging really the cybersecurity development area because so many tools and those standard technologies are typically what sometimes it makes it very difficult for everybody to work upon. There's of course a number of components, and over the next let's say 2 days we'll be talking about some of those components. But in many cases, also from the manufacturer's side, it has to be a risk-driven approach. So you take it very much holistically from the enterprise. What's the risk basically from there on, and then seeing throughout the different components afterwards, how can we find the necessary technical means to further secure. Now, tomorrow afternoon we'll be talking about some of the electronics, so the embedded security. We'll also be talking about some of the software components. Definitely also a contribution from Ross in that space. So what's your feeling, Tom? How would we be able to make a strong move forward in this particular challenge?
Yeah, so I think and I echo a lot of what Reinhard said. Right now we see two different camps, so to speak. So we see the manufacturers who are focused on getting their robots out there. And then we see the companies that are looking at the cybersecurity. I agree that these manufacturers of robots should take into account cybersecurity earlier, but they are not. And so we need to see, how do we partner these companies together and not make it adversarial. So not make it as a, hey, look, we found this flaw in your hardware or your system and expose it. Rather work with manufacturers. But I think that's tough. The manufacturers are just not focused on it as they need to be. So it's going to be an interesting development. It's going to be fun to watch, to see what happens as this becomes a bigger issue and needs to be better addressed.
So what do you reckon, both of you, would be the real pivotal change in this space? And I don't want to move too fast ahead of this event, but since the two of you are here, I think it really helps us also understand in what types of directions that also from the cybersecurity land we need to move to. I mean, one thing is that we are trying to create awareness, and as I've explained earlier on in my opening talk, when we do this with people who are basically developing applications with robot systems, they do see the interest, and the awareness is of course a major thing. But there also has to be this attitude change, and then also from the manufacturer side, there needs to become much more also an appreciation that they need to push this to their customers. I think what we understand is that as long as the customer is not really asking for cybersecurity attached to it fully, then they're not going to move that fast. What is that also your feeling?
So I would agree there. I think raising awareness is a big part, and focusing on the customer, the end user. They're just not aware, right? When you go in and talk to any of these large deployments, and I've been in a couple of warehouses that have, over 100 of these AMRs on their warehouse floor, and they're just not aware. They are very focused on their facility, and they don't really think that somebody could come in and alter the direction and speed of any of their systems that are on the floor. And so trying to get them aware, and then having them ask the manufacturers, hey, what is your standard? There is no minimum standard, right? So I'm not one for regulation. I'm not pushing that we start that now, but there needs to be from the industry a common agreed platform of at least minimal acceptable practices, and then have this customer start asking, hey, does your robot meet these standards?
Yes. I fully agree with what you said. And in the mentioned warehouse example, it's even easier because this is a more or less closed environment driven by one operator. As soon as you go to more public spaces, and if you introduce this at home, the situation is quite more difficult. And the risk that someone tries to get control over a robot at home might be much higher than one thing which is protected professionally.
Okay, that's interesting. So we'll talk about standards definitely later on this afternoon. The certification component, and especially also to some of the policymakers here around, is of course something that we need to put some attention towards. We know that from a European side, products are going to have to be certified. So there's an ENISA development going on in that space. There's also the radio equipment directive that's going to ask much more of those types of specific requirements. How that's going to pan out is really not certain, and it's also going to take some time. So on the US side, Tom, are there some specific regulatory frameworks that you are expecting that will be entering into the discussion domain maybe in 2021 and maybe already on paper in the same line?
Well, I would say right now the focus is around safety standards, and so there's a lot of work around, especially as these collaborative robots are deployed. And RIA and others are really focused on the safety standards. I think that's a great place to start. But there is not an effort, the same level of effort regarding cybersecurity issues. Yeah.
So in Europe, we have, for example, the machine directive, which gives a lot of insight what a actual machine in a factory needs to do. There is a revision ongoing. But for many other things which are outside the safety issue, it's currently the time to shape it.
Great.
Yeah. So okay. So I think that's a lot of potential work there that needs to be happening. There's a question coming in from Jonas, actually one of the panel members. Will the security of robots be improved if more open source frameworks and libraries will be used, and then which can also be publicly audited? And I think that's also relating to another talk that we'll have this afternoon, especially coming from the Global Atlantic Council, in this case, on the work that they've been doing specifically on supply chains and then software supply chains. It's also relating to one of the topics that we had on the agenda, but Alan unfortunately had to move to something else, but will be popping up the security bill of materials again in the not too far future. So what's your assessment on this? So do you think that when more open source frameworks and libraries will be used, they can be publicly audited, that there will be an improvement of that security?
I do think so. I think, you know, we're certainly seeing a wider usage of ROS and ROS Industrial and Secure ROS. I think that's going to help because that does set, in essence, it sets a standard. And so once you have more companies using a common platform, once vulnerabilities are found, they can be more easily addressed and more widely distributed. So I think that's going to help, but not everybody's going to use ROS, right? So so we can't just rely on that to kind of solve the problem, so to speak.
Yes. Reinhard?
Yeah, I can just agree. So ROS is very good, but mainly used in the prototypical stage. And quite a number of companies use it for testing out some new technology. And then they integrate it, for example, in their standard software framework, which is, of course, a proprietary thing. And this is exactly the problem we are facing. So I think it's a very good initiative to go for open source, which could be publicly audited. We have a lot of, in many other areas, we have software that is open source and is used. The question is to which extent, for which application area ROS is the right thing. And there are not so many alternative frameworks. And from another point of view, what many people would like to see is a more model-driven approach to software development for robotics. And this is currently not integrated with ROS, even if there are some European projects like Moses and others trying to combine the two worlds of model-driven and this ROS-like library structure approach. This is something which might come up in the future, but it takes a couple of years.
In the I would in this case I would start to counteract a bit of your arguments, because one of the biggest threats out there is basically what is the open standard that we are using on a continuous basis, which is called the internet. And the internet is really the big vulnerability out there of any time. So I wouldn't say that a specific custom type of software from the different robot manufacturers is helping out either. So I would also argue that it's probably better to have an operating system which is publicly available, that can be shared, but also that it can be much more made visible on where some of those security threats are. So the concept of the security bill of materials is really to come up with not only the manufacturer's indication of this is my device which has these and these different components, but of course it has a number of vulnerabilities and these need to be managed. So I think that's really an important one, that there's much more transparency also from the manufacturer's side. Now, one thing that we're continuously forgetting to some extent here, a very interesting statistic I heard yesterday at the ROS Industrial Conference is that there's the whole market of manufacturers of robots, but there's also the whole market of system integrators, which is, in terms of economical size, equally large, if not bigger. So in what terms do you think that the system integrators actually have a much wider responsibility in this space than maybe also the manufacturers, or then maybe the operators of the robots? Reinhard, maybe I'll ask you first.
Okay, in this case, I think the interplay between the robot manufacturers and the system integrators must be in the way that the basis is there already given by the manufacturers in order to avoid too many, let's say, screwed on solutions, which are typically more vulnerable than anything else. So if it's already built in the base software of the robot itself, this helps the system integrator to do a good job and speed up the actual development of the application. And this is what we should aim at. So it needs to be integrated in both areas. And of course, the responsibility of a system integrator is quite large because you can make a system vulnerable even if you just screw together two systems which are per se as standalone components quite okay.
Tom?
So first, I think you're absolutely right. The integrators played a huge role. I mean, we here in the States, it's almost 2/3 of the cost of a deployment is related to the integrator, and you're only 1/3 of it is the actual hardware. And also, the integrators want to have the ability to access these systems to be able to monitor and provide service. So they're essentially opening a pipe into these robots. To allow them to do some of their jobs, and how secure is that? And certainly, I mean, if you've seen the news recently about all the U.S. governments being hacked by a third party that was providing updates that people didn't realize was happening, and I think that's the integrators are going to play a major role in this going forward.
Yeah, so tomorrow afternoon, thanks to Elias, we'll be having a system integrator that actually was also called in when an incident appeared, and a cybersecurity incident appeared. And we'll be having tomorrow afternoon a bit of that history being explained to us on how that worked. But apparently, they're also the first line of support in this case for many customers. That once a system doesn't work anymore, who do you call? Of course, the person that you have the maintenance contract with, that you have the installation with. But most of the system integrators don't even know themselves how cybersecurity really works. So a lot more needs to be done in that space as well. So one final thing that I would like to throw on the table here, which is also going to drive a little bit the discussions for the next 2 days, which has to do with what we call in IT space and basically in the domain of cloud services, shared responsibility. So shared responsibility basically is a concept whereby this is being defined. So whatever you do in your cloud environment, you have to be relying on what Amazon and Google provide you as an infrastructure, of course. But at the same time, it doesn't relieve you from leaving all of the doors open and forgetting that you have an identity and access management system that you need to manage. So that's the concept of a shared responsibility. Is that something that you think could work in an environment where you have, as I said, things like service level agreements, basically an environment where many organizations are just already aware and since the last 20 to 30 years pushing away their responsibility themselves and saying, we don't touch this. This is really the hand of our supplier. So Siemens has installed this. It's really Siemens' job to manage and to maintain all of this. What do you think?
Well, I think the problem is that the systems are getting so complex that it is hard to have that level of shared responsibility because some of the parties just don't have the understanding and knowledge to be able to do that. So I think you're right. It's a lot easier to push it off and say, all right, Siemens, you have all of it, and we're just going to have this little portion. And so I'm not sure that's going to work. It'll be interesting, right?
Yeah, fully agreed. I think the concept is quite nice, but the implementation very hard.
Right. Let's see that through. Gentlemen, I thank you a lot, both of you, for your contributions and inputs. Much appreciated. Tom, we'll be seeing you again tomorrow afternoon at the closing panel. And Reinhard, of course, you're very welcome to stay on and to spread the news and the message. And I'll be working together with you on maybe a bit of the research agenda for Robotics on cybersecurity.
Thank you so much. Thanks for the invitation again.
Thanks, Albert.
Bye.
Pleasure. So we'll switch gears here a bit. And Jim, good afternoon to you too. You're also dialing in from the US, so good morning in your case.
Morning. Afternoon.
Happy to have you here. Yeah, we set the scene a bit also for you to start exploring how basically standardization and yeah, even to a large extent also ISO 99 and IEC 62443 is being certified. A lot of it is expected from certification and standardization, as you hear. I think in the space whereby robotics are being installed, usually in industrial robotics, we do see that there's quite a lot of opportunity for those manufacturers, but also for the system integrators and the operators to understand where cybersecurity in an industrial context really need to take place. So if you would be able to guide us a bit in that space and also highlight a bit where you see the needs towards robotic systems, that would be superb.
Sure. So a little bit about me. I work, my name is Jim Gilson. I am a principal industrial consultant for Dragos. I am also the co-chair of the ISA 99 committee, and I'll explain a little bit more about the numbers and the committee in a minute. A little bit about Dragos, if you don't know, we are a monitoring and detection vendor. But we're more than that. So we have a product that does monitoring and detection within the ICS OT environment. Basically we sense alerts and events. We're not a SIEM product in and of itself, but we do have a lot of very good alerting capability of the specific industrial environment pieces. So we actually study, we have a division within our company that does threat reporting and threat intel. And so we have a reporting group from that, and that feeds into our platform. And then we also have, I work in the professional services side. And so I work as a consultant with asset owners and vendors to do assessments on their products and their systems. So I will go into an asset owner and do an assessment on their overall architecture or a vulnerability assessment. We have people that do pen tests. And then as part of that, we also have incident response groups. So our incident responders have actually responded to things like the Trisis malware. We've had people respond to the Ricane power incident. So we have some good incident response capabilities as well. So taking a look at the ISA IEC 62443 series, we are a security standard for all industrial and automation and control systems. Normally it's industrial control systems or automation systems. We just melded the two and created the term industrial automation and control systems. And basically this standard series covers all systems that can affect or influence the safe, secure, and reliable operation of industrial processes. So we have a very broad scope that covers a lot of areas we didn't originally think about. So we originally started this with a very process industry focus, process and also manufacturing. But a lot of the main players, the asset owners that we had when we first began were industrial, chemical manufacturers, oil and gas companies. And then we also had some food and pharma. So we had some groups that were involved in that as well. What we've found over the years since we started this, we actually started the committee in 2002. And we found that we've ended up getting applied to many other industries that didn't originally occur to us. Things like transportation systems or medical systems, where they are industrial in the fact that they are not standard computers, and they have high reliability requirements and availability requirements and things like that. but they're outside of the traditional industrial space. So today I'll give a little bit of a discussion overview of the series itself and the different committees that are involved in developing it. I'll give some of the key concepts in the series, and then I'll give a little bit of discussion about the future direction. And if you have questions, feel free to post them in the Q&A or the chat, and we'll have we can have some discussion. So a little bit about the overview. I don't expect you to remember this, but the main thing to take out of here is that we're not just one document. It's actually a series of 14 documents right now that are either in development, published, or planned. And we have another probably like 3 or 4 that are coming up soon in the future direction. So it's a fairly broad series with a lot of different aspects to it. And we've broken it up right now. The current breakdown is based on sort of the type of thing we're looking at. So the first series, the -1 series, is general standards that apply across the board to the entire series. The second series, the -2 series, this is different policies and procedures. So we start with things like the asset owner themselves, and then we have one on patch management. We have one specifically for service providers. Think about integrators or different types of service providers, like a maintenance service provider or something. And then we also have some other discussions on guidance and how to do some of the assessment and measurement of the different series. Below that, we get into some more of the technical aspects. And so we're looking at system level technical requirements. So 3.3 is one of the main standards that has a catalog of controls. And then 3.2 is effectively a modification of the ISO 27005 risk management process that adapts it to the 62443 series. So, and then below that, we get into components. So you were discussing having standards for maybe a robot manufacturer or say a packaging line or something that's produced as a system of components. And that would get down into the component level requirements where you have both product development lifecycle requirements. So that would be the policies and procedures of how the product developer would actually integrate security into their products. And then you also have the technical requirements, which are an extension of the system level requirements down to the component level. So what do the individual components need to actually incorporate into their own, into the devices to enable system level requirements. So I've thrown a lot of numbers here. The series is produced by 2 different main committees. The ISA 99 committee, the ISA is the International Society of Automation, and the ISA 99 committee is the group that has up to this point developed the bulk of the technical content in the series. Only one of the documents in the series, the integrator one, was originally developed at the IEC level and then adopted down by ISA. There's some current work going on in IEC, and so that is based out of the TC65 Working Group 10. Both groups basically produce the same technical content within their documents. So typically the way we work is ISA 99 produces produces the technical content in most cases, and then we actually fork the document when it comes time for publication or voting. And so we create one version that is using the ISA boilerplate information and one version that uses the IEC boilerplate information. And then we send them both out. One goes to ISA to vote or for publication, and one goes to IEC for vote or publication. We also work in conjunction. We have liaison agreements to the JTC1 SE27 group, which develops the 27000 series on IT security. So we are working with them to try and be consistent. And so they have an actual voting say in the standard as well, so that we're trying to at least be cohabitate in the same world, since a lot of times asset owners may have a program within their organization that's based on 27000. We at least have a relationship to that and can show how a security program that's developed using 62443 can actually merge with and be consistent with 27000. Now I see that there is a, there we go. Okay, so that is that series. Now some of the key concepts. One of the first things that we had to do was actually establish some names for the roles. When you get into trying to integrate with large numbers of different varying industries or verticals, or even different ways that companies do business, you run into a lot of terminology issues. So fairly standard in standards is to actually try and define a clear set that you can work with, of terms that you can work with, so that you can actually have a similar conversation across everyone. So because the terms related to different groups, whether it is an end user or is it an integrator, is an integrator a company, or is it an engineering group within inside an organization? Is it a large vendor that has a service organization? So in order to separate out the organizational structures and the company structures from the actual role and task that role has to do within the series, we created these names that we use within the series, that we try and use consistently throughout the series. So asset owners are going to be the end users, the one that's actually accountable in case something goes wrong. And typically, a lot of times, the asset owner may also be the operator as well. So if you're a large paper manufacturing or you're an auto manufacturing plant, the auto manufacturer is both the asset owner and operator of that plant. And then when we get into service providers, this may be an integration service provider. So an integration service provider may be during the design and build phase. And then once you get into the operations and maintenance phase, maybe you have a service level agreement with that integrator to actually maintain the systems. And so then they would transfer from being an integrator to a maintenance service provider. But that all depends on who's actually doing the maintenance task within your O&M process. And then you also have product suppliers. And so a product may be an individual component. So it may be a PLC, maybe it's not even a PLC, maybe it's one card within a PLC. Say you've got a ControlLogix PLC, but you've got a ProSoft card within it to connect to this particular network. Well, the ProSoft would be one component. The ControlLogix PLC would be another component that consists of individual components. And so you get into larger systems. Maybe you've got a skid manufacturer that is actually producing a large cabinet of equipment. And so they would sell that as a product to integrate in. Maybe it's an integrator that's actually taking and actually combining a bunch of systems into a larger scale. So this is where you get into the product could be one or many individual pieces that are put together as a system. So, and these were important for us to talk about, because when we get into the life cycle, then you get into things like RACI charts of who's responsible, accountable, who you have to inform, who has to be consulted as part of the different pieces within the life cycle. And so we use a variant of the IEC 24748 life cycle that goes between specification all the way out to decommissioning. And so the green circles here, that's typically what's considered all of the things that have to happen before you start normal operations. And then the blue boxes or the blue circles are where you get into operations and maintenance. So this is the continuous operations and maintenance phase, where you may have a plant that's up and running for 20 years. And so now you're into operations and maintenance. But there has to be some feedback into, well, we're now going to develop a new, we're going to take this manufacturing line down and retool it for a new operation. And I know that the discussion earlier this morning or afternoon for you all was about retooling things like the ventilator lines to produce ventilators, or to retool for this. I know auto manufacturers will typically retool their plants every 3 to 5 to 10 years. So that's going to be where you have to go back to that spec and design phase to possibly integrate in some new technology. One of the biggest things that's actually occurred that we've seen really translate well is a zone and conduit model. And so this is where you can actually go and start to segment your internal network structure to help you reduce the impact of a possible incident, to actually help with reliability and performance aspects. I know when you get into things like robotics lines, you're dealing with 10 millisecond control cycles. When you're getting into things like pulp and paper, now you're having to do things like use real-time communications, hardware-based real-time communications, whether it's Ethernet IP-based using like the IEEE 1588 protocol, or it's like Siemens-based where you're getting into the asynchronous real-time Profinet, where you've actually got to get down into the microseconds level of control cycles on things. And so now the added benefit of segmenting your network is that you can actually concentrate on the performance aspects of certain parts of your network to actually help that reliability of your system. So technically, the zones and conduits model is based on groups of security requirements. But from a consultant point of view, every time I go in and help a network and help an asset owner, we concentrate on trying to overlay that network structure or that zone and conduit structure based on what makes sense to the organization, based on how they break their systems down, how they actually go through and organize their thoughts. Is it line 1? Is it line 2? Is it robot cell 359? And so we break things down in a logical way so that when you come to it and understand the network structure translates directly to the process structure. That way it's easier to explain when you get into trying to understand the cybersecurity aspects. Another thing we've done, at least from the technical point of view, is tried to expand on the typical cybersecurity aspects of confidentiality, integrity, and availability. We've understood that there's more aspects that need to be described. And so we've developed the foundational requirements. We broke out the traditional access control into two different pieces because there's so many different requirements associated with that. And then we don't just concentrate on data integrity, we concentrate on the system integrity. So is the system operating the way it's supposed to be? Data confidentiality, restricted data flow, that's a lot of network segmentation. Timely response to events, that's making sure that you can respond to an incident if it does happen. And then resource availability. So not just data availability, not just individual device availability, but is the whole system available when it needs to be? Can you actually have a safe shutdown? Is your e-stop in the robot work cell somehow connected electronically in a way that can be spoofed out? So an example of this might be something like in the Triconics attack that happened in the process industry. So you may not fully understand all the details, but basically there was some malware written specifically for the Triconics safety systems that would actually even spoof out the key position on the safety PLC. So the safety PLC had a key for run, a program, stop, so program, remote, or run. And that key position was only stored as an electronic variable within the PLC, and the malware actually spoofed out that key position. It wasn't hardwired into the system. It was actually just a tag in there that was able to actually be spoofed out and changed. So things like that, making sure that you're not subject to some of those issues as well. Another one is getting into security levels. So to go along with these foundational requirements, we've developed a series of security levels. So we try and base the security levels originally on the type of attacker that we were trying to mitigate against. And it's used, this security levels concept is used for both design phases. So as you're building a system, you design it to be able to react and deal with a certain type of attacker. And then as you go in and do an assessment, you come in behind it and say, okay, given the evidence that you provided, what level would it actually have been able to deal with? And then what you can do from that is you can design what are called compensating countermeasures to basically assist in the existing native capabilities to add additional features in maybe technical features. Maybe you needed additional pieces of additional components to add. Maybe you need additional policies and procedures to go along with it. Maybe so additional policies and procedures, additional steps that you have to go through that will help basically compensate for the lack of security within the devices themselves. And in the industrial environment, that's fairly common that you have other practices. So in the control room that is controlling the nuclear power plant, you don't want screen locks turned on. You don't want to have an operator mistype their password in order to shut down the nuclear plant if you're suddenly going into a situation, or you don't want to have a situation where the e-stop malfunctions and you can't shut down the robot, or the safety interlocks don't function properly because somebody didn't log in to their account or something like that. So you may have physical controls around that control center or around those safety interlocks or different systems that can provide you with access control requirements. So things like a control room where they have to badge in, and there's a guard standing there making sure that the person's photo on the badge matches the photo of the person that they just badged in, to ensure that they can go into that room. And so within that room, the access control requirements are reduced, but there's compensating countermeasures in place to allow for the same level of identification of the people that are involved in that area. So the idea of this compensating countermeasures comes in quite a bit. When we look at the different levels, you've got one is casual and coincidental. This is leaving the recipe to Coke out on the desk, having passwords pasted on monitors, having having passwords go in the clear across a network, things like that, that are things that are easily fixed with basic security hygiene kind of techniques. Then when you get into level 2, now you're getting into some technical attacks, but level 2 really is dealing with standard kind of attacks. So now you're dealing with maybe automated internet-based attacks. You're dealing with bleed over from the IT. Maybe it's generic malware. Maybe you're dealing with Conficker or Slammer or Mariposa botnets or things like that have gotten in because somebody brought in a USB stick with some generic malware that they had and put it into your systems. So there's a lot of these cases that still exist today. I ran into this kind of situation last year where there was a malware botnet that had been sitting in an industrial environment for years, and no one had really paid attention to it because it really wasn't doing anything. It was getting blocked by the firewall. It really wasn't affecting production very much. So they just kind of left it there because it would have actually been more costly for them to take down that system and clean it during production hours than it would have to just leave it there and let it fester until they did a full upgrade. And then level 3 and level 4 is where you're getting into more of the actual potential attacker kind of situation. And so level 3, you're dealing with maybe insiders, maybe disgruntled employees, operators, maintenance personnel, contractors. So people that know something about industrial space, maybe they don't fully understand the entire level of what you're dealing with, but you're dealing with somebody that knows about that space and understands the processes that are involved. Now, level 4, you're getting into privileged users. So now you're getting into trying to defend against the system administrator, the engineer that programmed all the PLCs, the attacker. We don't talk about like Stuxnet level attack, but this is where you're trying to actually defend against people that are really know all the ins and outs of your systems, or have been in your systems for long enough to really fully understand what's going on. So these are great. Security levels are great for doing technical requirements. When you get into trying to understand a process itself, now you get into looking at maturity levels. And I'll probably try and speed this up. I think this is the last one of my key concepts, but maturity levels really help us to understand how well an organization is following its policies and procedures. How well are they written? How well are they actually managed? Do they have feedback mechanisms to really integrate with their design process? So, and we generally follow the CMMI, which is the ISACA or the Software Engineering Institute method for measuring maturity model indexes. Future direction, where are we kind of going? We're really trying to look at consistency. So a lot of our standards in that series were developed at different times and different levels of understanding of the environment as we've like grown over the years. As I said, we started in 2002. As we've grown, things have really changed over the time. So some of the terms and definitions have gotten a little bit more well understood. Some of the concepts that we're using across the series have really developed over that time. And so now we're trying to go back and look at each one of the standards and see how we can better utilize those concepts. And we've also noticed that a lot of the standards kind of grew up with different organizational structures around our requirements. So we're trying to go back and now reorganize the requirements. So not change the requirements fundamentally, but just reorganize them so they all make sense a little better. And so we can show better relationships between the requirements in one of the standards and the other. So we can actually show mappings better. So we can show traceability of one requirement to another a lot easier. We're also looking into assessment. So we're trying to develop a way to merge the technical security levels with the maturity levels to create an overall security program rating. We're looking into what are called profiles. So there's an effort right now within the IEC to create what's called a horizontal standard. So since cybersecurity crosses over all sorts of different industries and verticals, they're looking to say that we potentially will we'll abstract a lot of the basic security requirements from industrial and take them up to a higher level to say, okay, this is general cybersecurity, and then here we'll create individual profiles for specific industry verticals or types of users or something like that. That's still developing, but there's an effort to sort of look at doing that within the IEC level. And then certification, there's looking to try and work to develop better certification around these standards. Right now, it's easier to look at some of the components or system level requirements and look to see how they might go and develop into some way of going and actually looking at certifying individual devices. And then we're also looking at providing a lot more guidance around the standards. So how can we actually develop some use cases of different industries, different verticals, different types of organizations, and then looking at the life cycle itself and how we can actually go and how an organization might be able to jump into the life cycle at different points. So right now, there's an effort within IEC, the IEC EE, to actually go and develop a certification. I think they're concentrating on 4.2 and 4.1, which are device level certifications. There's also an effort to try and expand that. There's a competing certification group called the ISA Secure, which is based out of the ISA group. So yeah, there's some different efforts to try and do certification around that. So we've got a couple questions here. That was the last actually slide that I had.
Okay, Jim, I think thank you very much for this. I think better is if we would take the questions a little bit later on the panel.
Sure.
Because I think we have also Trey that has joined, and I think Trey will need to leave in a couple of, will need to be leaving a little bit earlier on his side of the pond. He'll have some challenges as well. So, but thanks for that. I mean, that was very enlightening. I also have a couple of questions for you later on.
Sure.
But I think it was absolutely good to lay out the basis of where IEC 62443 today is for companies, how it was developed and set up, and so where it's going now. So highly appreciate that you made the time to do this. So stick on here for a couple of more minutes. And Trey, are you there? Somewhere.
I am. Good morning, everybody, or good afternoon, I guess, for you guys. Let me share my deck here quickly.
It's a bit of both worlds. So hi, Trey, and welcome. Good to see you.
Good to see you all. All right, let me...
You're not yet snowed under, it seems.
It is no, we are not. We are trying to be very restrained with the weather here. All right. So thanks to Ulrich and the group for the invitation, and good to be able to speak with you guys. What I'm going to do quickly is just run through some research that our group here at the Atlantic Council has been doing on software supply chain security, in particular thinking about open source, given the work that many of you do. So quickly, my name is Trey Herr. I run the Atlantic Council Cyber Statecraft Initiative. We are a policy and technology research organization based in Washington, D.C., focusing primarily on information security, and in the case of this brief, software supply chains. So this project is about a year's worth of work with the team here at the council, trying to pull together actual data on attacks on the software supply chain. Something where almost everyone you talk to has an example of an attack that they've seen that's impacted them, but very few have been able to actually pull together a lot of systematic evidence of how these attacks impact organizations and developers over time. So quickly, a couple of takeaways from what we've seen in this research. First is we see a lot of activity by states targeting the software supply chain. This week being a really good example, and we'll talk a little bit about the Sunburst attack that's occupying a lot of attention here in the States. Second, there are a number of attacks that try to undermine software signing certificates and public key cryptography. The key takeaway for this, I think for this community, is the mechanism that you're attempting to use to assert trustworthiness in your code. If you load something up on a GitHub, pull that as a dependency into a product or a project that you have, asserting that what you're downloading is actually what the developer committed to that repo. Public key cryptography is crucial in asserting that. And so attackers go after that assertion of trust or find other ways to undermine it. For example, slipping malware into a trusted repository or trying to have it signed by a software signing certificate. Third, 27% of the attacks that we observed in the last 10 years came from typically more sophisticated actors and targeted software updates. So when you're pulling new versions of code, be it open source or proprietary, that is a really crucial pivot point of trust. It's where attackers like to go, because typically the validation, transferring that transitivity of trust between the developing organization and the use organization, that is a difficult barrier to jump. And so it's a vulnerable hop for attackers. Fourth, we see a number of attacks targeting widely used open source projects on the web. And fifth, 22% of these attacks targeted app stores and developer tools. The app stores is probably less a concern for this community, but the developer tools is a really interesting one. Where trying to undermine compilers or mobile software development kits gives attackers the ability to insert malicious functionality in all subsequent products or software developed with that tool until discovered, which is a really efficient attack and a really pernicious one. So I won't go through the chart on the right in too much detail. Couple of big takeaways. First, figure 1 shows the set of attacks and disclosures. So the data set includes 115 events, 82 of which are attacks and 33 of which are software vulnerabilities or disclosures that could have resulted in a supply chain attack. And this is the distribution of those attacks and disclosures over the last decade. The second figure shows the distribution of those attacks and disclosures by the actual code base that they affected. So multiple cases of first-party proprietary software, third-party applications and firmware, and then a large number of open source attacks. The big takeaways from this first is software supply chain attacks are popular. They present a really efficient bang for your buck for the attacker. The ability to compromise one organization and potentially affect tens, if not hundreds of thousands of users is too compelling to ignore. Second, attacks that utilize software supply chain vulnerabilities tend to be highly impactful. Because of that trust in updates and because of that trust often placed upstream in the dependencies on products that you're using, the ability to get inside of that trusted loop means attackers are bypassing a lot of the traditional security controls, especially the application layer, that we try to apply to detect that sort of malicious behavior. And so it creates an additional challenge from the security standpoint of having to look for atypical behavior in organizations. And third, and this is just to undermine the supply chain vector is something that we see used by states in really prominent ways, usually for more systemic effect. So this is a quick summary of the data set. As I said, 82 attacks and 33 disclosures. Thinking about the open source community in particular, what I'm going to talk about quickly at the end is some recommendations for how to address these issues. But I want to show quickly with this graph two things. One, while I recognize this is a very waterfall development process, we can have debates and had debates, over weeks and weeks about what the one generalizable way to model software development is, and you'll never really come to a great answer. So we picked something that we thought was relatively simple as a way to represent different stages of development, or at least different tasks in development and deployment of software, so that we could show the distribution of these attacks and disclosures over time. And I want to draw attention to, I believe it's in my next slide, if I can get to it. I want to draw attention to that hijacked updates piece, because this is a really pernicious vector, especially for folks working in the open source community, where as you're pulling code, it's already compromised. So the Sunburst attack that's been dominating headlines here in the United States, and I think in many cases around the world, just because of the significant size and impact of the actual compromise, ended up as a hijack update, but actually began as an attack on this vendor, SolarWinds, which manufactured a network management tool, effectively something that allowed you to track and identify anomalous behavior on networks and manage traffic flow. The attack started as a compromise to a library in that product's software. And so attackers were able to gain access to the SolarWinds as an organization's network and compromise this library before it was pulled into the development pipeline for this Orion software. So the initial compromise happens back here at the system design stage. They then are pulled, that malicious library and that malware is pulled forward into SolarWinds' traditional update channel and pushed out to customers. The challenge that SolarWinds and the Sunburst attack really pose is twofold. First, there's no reason for an organization receiving that update to assume it's malicious, in that there, as a federal agency like the Department of Commerce, or as an organization like MIT CSAIL or the Robotics Lab, I'm not in a position to validate the security of that product, aside from validating that what I downloaded is in fact what the developer wanted to give me. The second problem is the sophistication of the attack, while not substantial, right? We've seen a lot of instances of this kind of supply chain compromise before, and I want to underline it's not exceptional. We've seen state-affiliated groups, we've seen Russian-affiliated groups go after administrative and network management and security tools before, exactly in this fashion, in order to get access to usually highly permissioned accounts or devices on target networks. The other challenge is this is not somewhere where organizations typically look for a threat. Again, because it's a security tool, it's not exposed as widely to the internet. Its users are typically more knowledgeable. And so it presents us a different challenge, having to almost look within the organization and within the developer workflow to try to address that risk. So quickly, what can we do, and what can you do in thinking about how to address these kinds of attacks? The recommendations that we have here are both for policymakers, but also for developers and practitioners in industry. And the way that we approach this is really to say three things. First, it's got to be easier to deploy software securely. A lot of the focus in security controls and standards over the last decade and a half, you think about the secure software development lifecycle, for example, a lot of those efforts have been focused on writing secure software. Far fewer of those approaches have been focused on deploying secure software and doing that, managing that secure deployment throughout software's lifecycle. So a number of the recommendations we make are really to take existing controls, not to create new requirements, not to create new standards bodies or even standards or processes, but just to take existing controls and pull them into a means, an automated method that developers can integrate cleanly into their workflow to make it much easier to work in a secure fashion and deploy code securely. Second is we really concentrate on open source. And I know there's a number of folks that are thinking and working in and around open source, and so I want to talk about this for a second. The challenge with the open source ecosystems, recognizing it's a huge and diverse set of cultures and development paradigms, the issue is not a cultural one. There's nothing that we found that said, well, people who build open source just don't think about security or anything. I mean, that's a sort of a very cheap and detrimental trope that you hear from people that don't really understand technology very well. And it's not fair to the communities that are building this code, because in many cases, the projects that they're committing to are being used incredibly widely, and they're innovating in really rapid and interesting ways. And so to just push all of that functionality away and say, well, it's insecure, we can't use it, is a huge mistake. We take a different tack, which is to say, there are parts of the open source community that recognize that their projects and their code is used in really crucial ways. The libraries implementing SSL and TLS are a good example, right? OpenSSL's a huge pivot point in the trust architecture of the internet. And the team or I should say the team now, obviously was not a huge group before, that commits to that project recognizes the significance of that. But it's not always true in other cases. Humble statistics and spatial awareness modeling packages, things that you'll find in the Python library, these may not have at first glance the sort of broad significance that something like a cryptographic library or an implementation library for cryptographic protocols would scream out. The challenge is understanding that that package 2 or 3 steps removed may be integrated into a project or may be integrated into a piece of software, which is highly consequential and really does pose significant security risks if compromised. And so rather than asking every graduate student and every open source researcher and every person in industry working or committing to these projects to be Nostradamus and to try to predict every possible way that their project or their software could be used, we're coming back and asking governments in the US and in the EU to put money into open grant application pools so that projects can come and apply for funding specifically for security management, additional volunteers, tools, access to standard bodies, but also for governments to be able to selectively award funds to projects that they see of rising or significant import. Money as a way to address the deficit in resources, and the discussion about money as a way to address the deficit in attention, especially from the policy community. And then just quickly on countering systemic threats, this is something that Sunburst really underlines the significance of attacks that try to ripple throughout a large array of organizations. And for this community, I would really just say, being active in discussions with policymakers, especially in the EU, is crucial, because there has to be a partnership between industry, the security community, and governments. And so we see a lot of activity around supply chain security of 5G and regulating digital markets. But as this discussion of how the US and nations in the EU and in Asia are going to be able to take joint action in response to these kind of threats and make significant new changes to the requirements that certain large technology vendors have to adhere to if they're going to sell to governments, that work really has to happen in partnership with industry, or else it creates something that risks being really significantly flawed and tone deaf. One thing I do want to flag as well, because I know it's come up in the discussion, is the software bill of materials. So the SBOM effort, for those that aren't familiar, is effectively a way to create a nutritional label for software. So if you could imagine embedding a dependency graph for a product and specifying all of its metadata in terms of code that's been included in it, where that code comes from and what it depends on, the SBOM creates a really useful and discrete data type to be able to track this web of relationships in software across this ecosystem. And so one of the things that we recommend in this project is to take that SBOM effort and really internationalize it. So I'm excited to see it's on the agenda here. I think it's something it's crucial that it's done globally, and that we see vendors and open source projects really adopting this together, because it's going to give us a new language to talk about these risks, and it's going to raise a lot of visibility and increase transparency to understand where there are sources of risk that we didn't know about. Where there's one project that was written by, say a German graduate student 5 years ago that everyone just uses but hasn't been updated in a while, is now become this sort of hugely important node in a development ecosystem. So really trying to understand that. So let me wrap the screen share there. And I see there were a couple of questions in chat just before I run out here.
I think most questions are related to Jim, Trey. So You're good.
Okay, excellent. Ulrich, thank you again. I apologize everybody for having to run quickly to another event, but I hope the rest of the conversation is great. And thanks again for being able to spend some time with you this morning.
Well, thank you very much, Jim. In any case, sorry, now I'm completely getting confused. Thank you very much, Trey, for picking it up and for definitely also talking about the research that you've been doing here on this domain. So I'd say one major question that we of course have is in relation to the traditional software vendors in this case. So especially also in the way that we addressed it just before, I think it has a great importance that the different system integrators have a knowledge about how to integrate, and so also from their side, there's a high responsibility, of course. Questionable in all of this concept is how can we build in there the different levels of controls in order to ensure that the software that's being provided is secured, not only secure, but in this case cyber secured, and further along probably also safe. So any thoughts on how to address also, for instance, in this case, traditional software vendors, and then specifically with their bespoke solutions, with their own custom solutions, because of course most of the things that you talked about here have to do slightly a little bit more towards the open source. Trey, and I think he might have fled the panel here. Okay, we'll have to get him back then. No problem at all. So the question has been recorded, and I'll pick it up again with Trey. But I think he probably has had an issue. So we'll continue. We have a couple of minutes left, but we'll pick up on the questions and the answers. I see that Jim has been extremely active in the Q&A and in the chat. So I will pick that up in a second, Jim. Reda, it appears to be that you're quite available here.
Yeah, hi everybody. Thanks, Eric, for the invitation.
My pleasure. So thank you very much for joining. And since Trey has left the building, we can continue in any case talking about some of the European developments which are going on. And well, I think it's great to have you here representing both Sequoia and also some of the works that you guys are doing as a private company within this project. About a year and a half ago, have been two major projects awarded by the European Commission to do cybersecurity for manufacturing cybersecurity, and Sequoia being one of those two projects, where there's many different components in there that relate to what the future manufacturing environment is going to look like when it comes to trying to secure it or cybersecure it better. And I think it has quite a number of interesting components, amongst others also collaborative robots. But Reda, I'll let you do the talking and the introductions about all of this.
Okay, thanks. I need to save bandwidth. I will cut my video, but I will be back after the talk. So just a small introduction. So my name is Reda. So I'm leading the cybersecurity team at IRT Systemix. So IRT is a research and technology organization. It's part of the French Institute of Technology, which is a group of 8 institutes spread around France. So I'll be speaking, as Eric said, about Sequoia. So Sequoia stands for Secure Collaborative Intelligent Industrial Assets. It has been granted funding by H2020 project by the European Commission through the program ICT8 of last year. That was aiming to secure, to bring security and resilience for collaborative manufacturing environments. So just a kind of context. So as you know, the driving force of digital transformation of industry tend to tear down the verticality of traditional supply chain. This leads to a more horizontal value chain. This value chain does not only involve suppliers and subcontractors, but reach more actively to the customer side, as well as a number of service providers, among them what we call cloud manufacturing service providers, which are likely to play a huge important role in future manufacturing activities. So in the picture, what we want to kind of attract your attention to is the emergence of new concepts, new actors, new flows, and new assets. Among the actors, we, as you can see, we have also fab labs and agile factories. These new factory styles will provide option for distributed manufacturing and enhanced product customization. It even might, in the future, lead to what we call make your own product approach, with probably the use of affordable additive manufacturing techniques. The other actors are, as I said, cloud manufacturing service providers and similar IT service provider that will have a huge role and share in the future manufacturing value chain. They will provide access to information and computing resource, of course. In terms of flows, we identify and we will notice the apparition of two distinct flows. The distributed process flow, as the verticality of traditional supply chain will be torn apart by the enhanced flexibility and configurability of new manufacturing assets. This will probably lead to production models relying on networks of factories rather than real centralized manufacturing plants. Also, the use of additive manufacturing techniques heavily supports this trend, with the ability to produce much smaller scale and customized products and at very competitive costs. The second flow is with respect to information flow. In the picture, it's worth highlighting the growing prevalence of information flow. This data-centric approach of future industry has been intensively explored through initiative carried out by the Industrial Data Space Association and more recently Boost 4.0 project. Finally, we notice also the appearance of new artifacts. Among these artifacts, and what will interest us, is the smart manufacturing assets, the deployment of smart sensors and actuators driven by industrial IoTs, and manufacturing artificial intelligence shall transform the floor and the logistic area. So the key drivers here are the decrease of cost and smart sensors. But most interestingly, the collaborative robots will increasingly support humans in their daily operation, providing greater flexibility than generic programmed robots. They also will provide greater robustness and availability with respect to human operators, and the potential ability to absorb in more efficient and let's say fast way the absorption of production peaks and lows more easily than traditional manufacturing. The last new artifact is the digital twins. So beyond sharing data with multiple stakeholders, it will have probably an interest in sharing models and simulation tools, supporting advanced manufacturing practice. And in Sequoia, one interesting usage of these digital twins is to use them as a mean to prepare people for the human preparedness dimension. So in Sequoia, the idea is to address four main use cases. So the first use case that is presented here is about integrating IoTs in three of Airbus aerospace manufacturing factories that are based in Spain. The idea is to be able to retrieve, save, and show historical data, to analyze and process the data, and to improve the aircraft manufacturing process. So with effective challenge in terms of human preparedness for cyber attacks with respect to the confidentiality and integrity of this data, but also machine preparedness for cyber attacks, and also challenge with respect to authentication and encryption of this data. The second use case is concerning automotive use case, which is piloted by Continental factories. So in this use case, the objective is to guarantee cybersecurity and safety of vehicles. The cryptographic keys and certificates need to be injected in ECUs, as you can see in this use case in production plants. The use case will try to build a cloud manufacturing environment to allow the distribution of keys and certificates between different stakeholders like OEMs or tier 1 actors, and to push them to the production plants of Continental in different locations. So of course there are huge challenges with respect to the resilience of the storage of these certificates and keys, but also for privacy reasons also need to make this technology privacy preserving. The third use case, I will try to describe it fastly. So it concerns naval and maritime manufacturing industry. And the main goal is to introduce remote maintenance operation to decrease cost of this maintenance and increase productivity. But the problem is due to the criticality of this environment, and opening their environment into to the internet will probably bring different threats levels like ransomwares, but also potential exfiltration of sensitive data, as we are dealing with military ships, and the risk of exfiltration of data is very high and with high impact. So the challenge here is to introduce different components to allow remote, secure and safe maintenance of industrial intelligent assets. And this is more or less the objective of this use case. Last but not least, we also aim to address a cross-sectorial use case that maybe concerns people around the microphone here, is about the collaborative robots. So the idea is to validate the safety and security functions that are related to the what we call AMR, so autonomous mobile robots, that are usually involved in basic shop floor logistic tasks, such as carrying out tools or materials from one place to another place. The involvement of collaborative robots aim to reduce the share of manual activities of low added value, which based on the numbers and the figures we have, still represent almost 70% of the manufacturing tasks in different sectors, and particularly in aerospace domain. These figures are a little bit low in automotive and maritime sector. So the idea of this use case is to introduce logistic automation as a main, let's say, driving objective, but also to introduce nice features, for instance, through the robots. While we want to preserve the safety of human operators, the argument would say that the robots would probably bring more safety to humans, and more specifically when it concerns to what we call lone worker protection in large factories. But also there are also a lot of sophisticated features that the robots can bring, like learning by demonstration. In terms of threat, the idea is to make the integration of robots in shop floors safe and secure for humans, but also to avoid that the robots are transformed or misleaded by humans through different, let's say, vectors. And one of these vectors that have been identified in Sequoia is the intelligence embedded in the robots, and particularly the machine learning or artificial intelligence-based intelligence. And more recently, as you may know, we have the increasing threat of adversarial machine learning, where people can fool machine learning algorithms or poison the data that are used to train these models. And the objective of this challenge is to be able to secure and add more trustworthiness in the machine learning and artificial intelligence softwares that are embedded in the robots. The last part is the cognitive and emotional behavior analytics to be able to detect anomalies with respect to human behaviors in shop floors. And this part, I think, Harvard can be of good help. So, as a summary of what we want to do, so Sequoia projects aim to address security within and beyond the shop floor. To do so, the project will fulfill the development of secure and collaborative manufacturing within and between the actors. From shop floor via the edge to the center cloud level, we will provide security mechanism and will make the collaboration secure through 4 dimensions of collaboration. So Sequoia address machine-to-machine collaboration, as you can see in the figure on the left, but also human-to-machine to make human-to-machine collaboration safe and secure. Human-to-humans also, and last but not least, organization-to-organization. Of course, the collaboration between organizations itself can be can apply at each of the lower levels. As always in manufacturing sector, availability is of paramount importance. This justifies a kind of safety-driven approach to security. In Sequoia, we want to bring 4 pillars of adding security and safety in collaborative manufacturing. 2 of them are more generic and technical challenge. The first one is end-to-end information security with concept like fine-grained access control, smart combined user and asset authentication, lightweight authentication, because also the problematic of embedding authentication mechanisms into IoT is something to be addressed. In terms of process safety, also Sequoia advocates an end-to-end process safety. The challenge relates to time-sensitive monitoring and control of manufacturing process. At the societal level, we want to ensure preparedness of people by training people, and for that we need to build collaborative industrial cyber range, a community-based industrial cyber range to share and profit from expertise and experience of each others, and testing platform for common testing environments. Last challenge category is to enforce social liability. This challenge relates with the definition of acceptance and observance of accountability framework for collaborative manufacturing. So the approach we followed in Sequoia is a kind of experience-based. So we collected information from market platforms, from other S2020 projects. We collect also information from reference models, architectures, and standards. And we build 3 granularity of architecture design. So the first one that had been delivered in this year was the high-level architecture of Sequoia. And now we are diving into the functional architecture of the submodules, and we will be able to design and specify the pilot architectures. So to do so, we did, as I said, a literature review on standards. And as you may know, one of the challenges was to be able to monitor and to integrate the standard ecosystem. The standard is quite complex and evolving, and also rich and diverse, because we have 4 sectors and 3, or at least 3, with preparedness pillars: information security, process safety, and social liability. And the objective was to find what are the relevant standards to be applied. And the question we tried to answer was to at least be able to have a gap analysis in terms of security and safety standard for connected factories and digital manufacturing. So first, we saw what was existing as standards. So we analyzed the trends and state-of-the-art as a desktop study. Then we collected experience from stakeholders to be able to answer the question, what are the experience and views of stakeholders on these gaps? last, we are starting to define the project high-level architecture, and the question was what are the future trends and how we can address them and potentially to help on standardization level. So for the reference architecture, I don't believe we will have time to deep dive on it, but so the idea of the reference architecture was to build on, as a starting point, to build on IRA. So IRA stands for Industrial Internet Reference Architecture, proposed by the Industrial Internet Consortium. So the objective was to rapidly identify and highlight common and important architectural concerns and design patterns. We chose IRA for many reasons, but among them that IRA recognized the essential role of artificial intelligence and analytics. IRA focused on applicability and interoperability across industries, and also IRA emphasized cross-industry versatility and also reusability of IoT technologies. So in the context of a Sequoia framework, the IRA 5 standard domains, namely control domain, operation domain, information domain, application domain, and business domain seem to apply rather well. So in the picture in yellow, we have the control domain. And in terms of component in the control domain, we are building next generation OT, operational technology intrusion detection system, to be able to analyze and detect intrusion on process or technology specific protocols. We are also developing lightweight industrial IoT authentication to allow robots and assets to integrate to shop floor in zero touch way. For the control domain, sorry, for the operation domain, which is in brown, we are building authentication, the server-side authentication, but also end-to-end encryption. A challenge here also to be able to do intrusion detection over encrypted data. So we're tackling this challenge also, and also to have combined user and asset authentication and authorization mechanism. In green, we have the information domain. So in the information domain, the main challenge, sorry, I should have animation there. Yeah. So in the green, so we have the information domain. So for the information domain, we are monitoring the behavior of robots and the correlation between the behavior of robots and the behavior of humans, and eventually to detect anomalies with respect to these behaviors. But also we are relying on digital twin simulation to be able to detect any deviation with respect to what is expected from the robot as a behavior. An important feature we're developing at the application domain, which is in Azure in the picture, is to develop a collaborative response team, cyber response team, that is supported by a collaborative SOC also. Last but not least, we are also trying to develop also collaborative forensic for post-ante investigation. This is also a challenge for so specific environment where we have complex assets like robots and industrial assets. I think I'm done. Yeah, in terms of impact, we're expecting to address or to bring different categories of impact: scientific, technological, operational, normative, and economic. With respect to robotics, we are expecting to have a better understanding and improvement in terms of artificial intelligence robustness, and particularly with respect to adversarial AI. In terms of technology, we aim to bring solutions of OT intrusion detection, and particularly on robotic protocol like the information exchange in ROS environments. For operational, we want to build a collaborative security training environment dedicated for human preparedness and raising skillfulness and awareness of people. In terms of normative, we have also the aim in terms of operational challenge to build OT SOC, as I said, collaborative SOC. In terms of normative, we want to build accountability framework for Industry 4.0 and provide secure guidelines for human-robot collaboration. And we want also to enhance the resilience of EU economy by using robots, as it has been discussed before. And the COVID-19 pandemic threat showed the advantage and added value of automation and robot in manufacturing and industries. Thank you for following this presentation. I'd be happy to answer your questions.
That was like a high-speed train, turbo-generated with a jet plane behind it, fast-forwarding everything that you wanted to tell about Sequoia and security for manufacturing environments that anybody ever needed to know. So great. Thank you very much, Reda. That was a great overview. Yeah, I think there's room for many different questions here and elements. Jim, you're back. Great. Jim, maybe a question for you. Have you paid a bit of attention to Reda's approach here? Because what I wanted to check is the idea that Reda has in terms of utilizing the IRA, basically the Industrial Internet Consortium's security reference architecture, is building a little bit upon IEC 62443 as well, but it goes a couple of steps further. And do you see in the? I mean, if you follow that, I don't expect you to have listened carefully to everything that Reda has been saying, because it was quite a lot. But I think from the overall perspective, do you think the approach that they're taking with the different manufacturing environments, with the different pieces and bits of technology, is a sensible approach?
Yeah, we just to let you know, our group does actually have a relationship with the Industrial Internet Consortium. And so we are actually trying to coordinate on those efforts. And roughly what they've shown in their architecture does follow a Purdue model-esque version of an architecture. They are able to take it to a much deeper level than we can, considering that we're trying to cross every industry, and they're focusing on a specific one. So, but I feel in general it follows an overall generally well accepted set of architecture plans. Yeah.
So that's check mark, Reda, that you can make. Approved by one of the co-chairs of the IEC 62443. Okay, so I think taking this one or two steps forward, I think we'd definitely be interested, of course, in your approaches towards the security modeling, towards the collaborative robots. So hope to see you coming back on that one at some point in time. But maybe we can already address it later on with Francesco from PAL. And at the same time, I think what my aim was for the participants here of the session is to give a bit of a perspective on how with different types of industries, with different types of security technologies, you really need to take a systematic approach on cybersecurity. So it doesn't really suffice to look into one particular component. It really has to be a holistic approach, and also working with different types of technologies. You have quite a lot of innovative technologies here that can be applied, and you're still looking to move beyond. So I'd say, what would you expect, Reda, would be the real major outcome of the activities at the end of the project? And I think it's due for another 2 years, something.
Yeah, it will. It's a 30-month project. It will end mid 2022.
Okay, so that's tomorrow.
Yeah.
So what do you expect, really? I mean, you've listed out quite a number of expected impacts, but from your side, what do you really would like to see coming out of this?
In general terms, or for robotics specifically?
Well, both. I mean, for robotics, it's pretty clear. I think the security guidelines, and if you can take it a little bit a step further, I think what we're really looking for is is not only guidelines, but also the use case that pass along with it. So those two definitely, but also in general terms.
I think the general terms will probably not be a specific component, but an approach or an idea of handling the collaborative dimension of cybersecurity. Because the collaboration in cybersecurity, the tools are not designed to allow collaboration. For instance, if I consider SOC tools or for investigation tools for the forensics, they're not at all designed for that. And even within the same company, people tend to have difficulty to collaborate and exchange information and solve collectively difficulties. So I think we definitely need new generation of SOC with enhanced collaboration feature to allow people within and cross industries collaborate to solve. I think the European Commission and at the European level through the ISAC, they are pushing the creation of a collaborative dimension of information sharing association and teams. The CERT also approach also is trying to push the collaboration within countries, European countries, but also across Europe. And I think one of the added value, if we can build, let's say, cross-sectorial collaboration, and even within a sector-specific collaboration platforms to allow monitoring, exchange of information, threat intelligence, I think it would be a high added value. But in terms of components, probably if we can make the artificial intelligence, because as we're moving to more data-driven, analytics-driven manufacturing with high customization, I think if we can make the artificial intelligence more robust against the new emerging threat that artificial AI represents, but also, as the question was raising, explainability of AI, because it's still hard to accept AI for a decision maker as they don't know what the decision is about and what is let's say the drivers and motivation of this decision. I think it's good also to push toward that direction.
Okay. Jim, back to you. There's been a lot of work going on in the chat and the Q&A. Just give a bit of a highlights what you've been addressing, because I was so focused on listening to Reda that I completely missed out on what you're been writing in the chat, and also for the viewers, of course, on the YouTube.
Yeah, so there were a couple questions on chat about certification and sort of like how the different organizations are organized. There's the standards effort to develop the standards themselves, and then there's some organizations that are doing certification on against those standards. So there is the ISA 99 committee, as well as the IEC IEC TC65 Working Group 10. So the IEC group is similar in structure to the ISO committees. So if you're familiar with those, they're national committees that provide national level voting and comments on a particular standard as part of the development process. And then there is the ISA group, International Society of Automation. We're technically under ANSI within the US. So we are not an IEC or an ISO level group, but we basically have a liaison agreement with IEC to co-develop these standards. So we have a separate voting process within ISA from the IEC group. But when we produce versions of the documents, we basically produce the same technical content within the standard with different boilerplate. And so effectively they're the same. Certification on those standards, there's two different groups right now doing certification against those. There's the IECEE, which is doing officially against the IEC version of the standard. And then ISA Secure, which officially goes against the ISA version of the standard. But as I said, the technical requirements, other than a few editorial differences, are effectively the same thing. So if you get a certification from one of the bodies, it will be it will represent a certain level of guarantee that they are following the standards. So,
okay. Thanks for that.
There were also some questions about safety and security. So we are actually working on some aspects of safety and security, along with the ISA 84 committee, which develops the IEC 61508 and 61511 specifically, which are process safety. And so it's related to like SIS systems and safety instrumented systems. So we're working with them to help develop some guidance around how to apply 62443 to safety systems. And much of that, much of those aspects will relate to whether you're dealing with process safety or like machine safety kind of aspects. So you'll still have to make those risk-based decisions on where and how you apply security to your safety systems. Generally, you're dealing with, in robotics, you're dealing with machine safety issues. So it's going to be safety interlocks, it's going to be e-stops, it's going to be things like that, versus dealing with shutting down a boiler system or a chemical reactor or something. But the processes and many of the same devices are used within the same industries.
Okay. Yeah, so I think there's actually quite a number of these elements that you indeed addressed also in the chat. So thanks for that. In any case, I'm not sure if you handled also. Yeah, I think it's also part of the safety. The question from Jonas in terms of the functional safety components testing and the relation to that, but I think it's also to a large extent. Okay, so to you then, Jim, in terms of the domain here of robotics, do you see any developments from within the committee or the, let's say, the overarching schemes to do more about cybersecurity compositions for robotics, or would you take that still on general level and try to take it from much more on a network segmentation perspective, and then also from there towards the different specifics of the subcommittees, or how would you see that moving forward?
So one of the things that we're always looking for is sort of partnerships or different aspects of industrial security. So having manufacturing involvement, having someone that comes from different industries to help us develop maybe some guidance around it. As I said, we're in the process of developing different use cases and different guidance for asset owners and for operators and product suppliers at different levels and in different industries. So as I said, we are involved with the Industrial Internet Consortium. I know I've had some connections with Industry 4.0 and some other aspects like that. So we are definitely connected to those groups. And I mean, right now, ISA 99 is around 1,200 people on our mailing list, and probably 75 to 100, probably 75 active participants in the committee. And then, I mean, our management group is around 20 for all of the different activities going on. So we have a fairly active group, and we've got hands in a lot of different places. So I'm sure there's some aspects of things that people are trying to bring in, but we're always looking to expand our user base and our activity, the people that are involved, so we get different perspectives. So we've had some interaction with things like medical systems and how they may apply it, and transportation systems. So these are things that are traditionally outside of the normal ICS space, and it brings a different perspective. So we're always looking for additional help with that.
Yeah, I think definitely, and to I say to the merit of what you guys have been doing, I think it's very clear that the standards and the mechanisms behind it, the philosophy of the models, are being picked up by the many in the ICS world, but also indeed beyond, because I think it's really a good basis to say, okay, the fundamentals of this segmentation, isolation, and then taking this further along should really be on the basis of industrial developments.
Mhm.
On the other hand, of course, and that's now I'm turning a little bit my cap. What we've seen in the information security world is, of course, that any type of wall that you start building is being teared down, in this case, by both the continuity and the developments of technologies, as well as basically those malicious actors out there that are just seeking their, let's say, the ways of the least resistance. And there's always a way of least resistance. So by building up walls and by saying, okay, let's try to segment and make sure that everybody is following the paths and the tunnels, aren't we basically too much focused on this? And shouldn't we be thinking about, for instance, in the concept of IoT edge devices, does it really still stand, and can it really still stand towards the future? Also, in the consideration of what Reda has been talking about, I mean, the much more collaborative security types of models, where we also see that data coming out of the manufacturing world has to move over to the information security domain, because there needs to be much more of a collaborative working there, and also towards basically the machines themselves. So any thoughts there? How do you see that moving towards the future?
So thinking about things like logistical and manufacturing execution systems, just-in-time manufacturing, additive manufacturing, like IIoT, a lot of that,
yes,
they are breaking what people have done to map Purdue levels to network architecture. So people automatically assume Purdue levels are a network architecture. They're not. It's actually a data flow architecture. And so you can have a different network architecture that doesn't look like a Purdue model. You can have things like IIoT that are coming in from the outside and working their way down. Purdue is really about data flows. So if you have data coming from sensors, going to a controller, going to an aggregator, going out to a historian or to some sort of manufacturing execution system, that's the data flow. The network architecture can break that data flow, and you have to work with the systems that you have. So if you are going out using some packet data radio through some internet service provider or through a cellular provider or something like that, you have to consider that as an untrusted channel. And so now how you actually monitor and manage that untrusted channel into your systems is something you have to consider as a risk-based decision in how you apply security around that channel. Same thing with a lot of the other industries where you've got architectures that don't follow the norms, where you have to worry about just different ways that they do business. I've been doing a lot of mining kind of industry recently, and it's like mining for power plants. So they'll mine coal, and then that information has to go out to the power plants on availability of the mining product, the coal that's coming out, and other situations. So there's a lot of those integrations that have to happen, and you have to consider those communication channels that go between it. Do you protect them between the systems the same way that you would internally within those systems? And there's a lot more integration between different groups within the same organization, or suppliers, vendor management, device vendors that want to have remote maintenance capability on the machine tools or things. So say a CNC manufacturer wants to have information coming back for maintenance, predictive maintenance capabilities that go out to them so that they can come in and do predictive maintenance to head off any problems that they're going to have, or same thing with a robotic work cell or a generator or something. So you have to consider those in your architecture as how you're going to design that secure communications to keep it from being a path into your systems. So.
Yeah, and that's exactly what I was aiming towards, because when we see, I mean, we are working on some activities under the umbrella of what's called connected factories, which is a European activity that's looking towards different pathways and trying also to connect different projects together. And one of those pathways is indeed the full autonomous factories or the hyper-connected factories. And so where we're tearing down the walls basically between those, to quote a relatively interesting Pink Floyd song, that's trying to focus on can we use all of the data available within one manufacturing environment and to monetize it much further towards the future as well. So we really are looking towards can we use those data sets and further optimize them, sharing them with others. So yeah, that brings it a little bit into a different perspective, because then you start mining all of those data, you push them somewhere in a cloud environment, and then you have to make it available again to a number of other parties to start working on, like the example that you gave in terms of, for instance, condition-based maintenance. So the CNC manufacturer machine builder that's actually wanting to use the machine data to optimize how basically the failure of the machine can be reduced. So yeah, as a typical use case. So according to you, that's still viable then to keep that up as a model?
Absolutely. Absolutely. And we work with that at my work with Drago. So we work with organizations to try and basically like figure out how they can do some of those aspects. It's fairly common for some of the larger manufacturers of, say, like power generators, wind turbines, or other types of devices to want to have some sort of predictive maintenance remote connection into the system. And so being able to design the architecture of the network and the access control requirements and the integrity and security requirements for that are just part of what you go through is your network architecture review. Okay.
So a question to the two of you. I mean, with all of the things that you mentioned, the great work on the IEC 62443, the ISO 99, the developing ways, the way that the industry is trying to endorse that still, we still see that quite a number of industries are trying to make up their own stuff. And Reda, you've been also investigating a bit the different standards as I did as well. And there's so many different standards out there that typically from a manufacturing company, it's difficult to choose from. So we are now planning a couple of activities on this, this being part of it. Another one planned on January 20th, where we'll have NIST and ENISA talking on some of their developments, also the Industrial Internet Consortium. So what does an organization need to consider when they're looking for to start with? I mean, with cybersecurity, one of the first things that they'll do is, okay, searching for who has done this before, what sort of use case can we use? Some of the use cases that Reda is now applying will be definitely useful. Some of the work done in ISO 99 will be absolutely useful. But where do they need to start? So what's really the baseline that they would need to look for, and why?
Do you want to go first?
Go ahead. Sorry.
So one thing I'll say is that probably 80% of all of the different ICS security standards are about the same.
Yeah.
So they may be written with slightly different phraseology or some different terms, but if you actually look across the requirements, they're probably about 80% the same. So NERC SIP, when you come to like US Power, the Nuclear Regulatory Commission standards, the ISA 62443, NIST SP 882 and 53, and cybersecurity framework, the Norway oil and gas standards. If you actually look through them, the requirements are relatively consistent. So pick which one you want and kind of stick with it, which one makes the most sense for your industry, but be aware that all of these other standards do exist, so that if you would like to pull from them, you can augment whatever program you're required to or you choose to use with a lot of the experience and guidance and possibly some additional requirements that come from those other standards, is what I would say.
Reda, your thoughts?
Yeah, I think the main challenge for large, let's say a large part of the companies, because we have large companies, I think they have the resource to have standards, to do gap analysis, and then to enforce the most appropriate, as Jane said, standards. And I think I share the observation that most of the standards are sharing, let's say, 80% of the basic concept guidelines that you can find in each standard. But the problem, I think, is the smaller or medium companies, where most of them, they cannot afford getting access to the standard first. And I think the good practice and the recommendation, like Enisa is sharing regularly, is a good starting point. So I think starting from let's say these guidelines is a good way to evaluate the real need with respect to the real standard requirements. And I think we need to make an effort to make standard accessible to the widest audience, including small and medium companies. And except that, I think the standard, it's not a matter whether choosing one standard or another standard. It's a matter of getting access to one standard and then sticking to this standard, and having in mind that the standard will give you a lower bound of, let's say, requirements you need to comply with, a risk assessment and a risk management to allow you to know what is the real threat, and your strategy is to find a good level of let's say, countermeasure to need to apply in terms of threat, in terms of also resource you have. And I think, yeah, the standard is good, but it's not sufficient. The idea is also to have a good evaluation of risk and threat, and then to be able to put in place the countermeasure that are in line with your strategy.
Okay, I think that's both a very sensible answer to also give to some of the companies out there listening in and trying to figure out what their next best standard would need to be. So, okay. I promised that I would talk a couple of minutes about the security bill of materials. So Alan Friedman, who I invited for today, had a very last minute dropout and was called away. So he had to promise me on his communion soul, I'm not sure if they have that in the US, but still, to come back on January 20th to talk about this. But I'll share some ideas, and I wanted to have a bit of an opinion also from all of my panelists here. So in that space, I'd say the security bill of materials, in a couple of minutes explained, is really about how can we take another challenge of the market today, and that is the different pieces of software, as were suggested by earlier on, were suggested earlier on also in terms of the supply chain. How can we deal with that? How can we cope with that? And so basically, and to take it to a further step, a software bill of materials, a security bill of materials in this case, is a list of ingredients, a nested inventory, and a formal record containing the details of what's actually part of the software of the different components. So if we would consider all of this in practice and take that as an example, for instance, in terms of a car, it would mean that we would get for every piece of software and robot in this case, we would get an understanding and a transparency guide on what the different components of the robot are. So not only in terms of the mechanical parts and components, but also when it comes to the embedded parts, the different microcontrollers, the different elements which are containing IoT instructions and so forth. And then finally, when it comes to of course the software being built upon it to steer whatever is needed. So the security bill of materials in this case, what the idea is and what we would like to take forward also on the European level together with Alan and with the NTIA is to start developing with a couple of different partners, mainly from the manufacturing side, but also from system integrator side and the project development side, is to try to come up with some baselines of those types of security bill of materials, and is to try to identify what it is, and then really come back to the to the core level of collaboration, as Reda was mentioning before. It's not really only about managing the incidents and sharing the ideas about the incidents that pop up. It's also about the maintenance and the management of the different systems, and it's also about really the design and the core elements of this. So, Jim, as basically a final question to you, have you come across with Alan and with the ideas of the security bill of materials, and what's your thought on this, also from your hat of Dragos now?
So yeah, I've actually come across people discussing software bill of materials, and even one, I think it's called distributed DBOM, distributed bill of materials. Yeah. It is a lofty goal to be able to do this. I think it's something that's great to have as an ideal of where we'd like to go. I think there's still a decade or 2 or 10 before we'll get to the point of actually being able to fully apply that. I think there's just...
How long has it taken for IAC to be fully adopted?
Yeah, I mean, it's taken 18 years now since we started. So, yeah. I mean, we're pretty far into that. And then I also have run into too many plants that I can't even get a basic asset list out of when I walk in to do an assessment. So if they don't even have a basic asset list, I'm not going to expect them to have a software bill of materials asset list. So it is something I would love to see. It would totally make the actual vulnerability assessment process much easier. I'm not hopeful that I'll actually be able to see it before I retire in an actual company, though.
Okay, we're going to do our utmost best to make at least that work and to see that at least some use cases can come out of it. But thanks a lot for your viewpoints there. And yeah, I will make also sure that that ISO 99 is being employed and deployed quite heavily, and try to include also you a little bit more on that side. And we'll search for contributors to the upcoming works, and certainly you can count on us to help doing that. Thank you very much, Jim, and thank you very much, Reda, for your contributions and for helping us out and giving your thoughts here. Very much appreciated. So we'll switch gears again and going away from a bit of the holistic perspective on cybersecurity, from the standards talk, and diving into our keynote speaker for today, Victor Vilches Mayoral from Alias Robotics. Hello, Victor. How are you doing?
Hey there, guys. Can you hear me?
Yes, we can hear you. We can see you.
All right.
Hear
Fantastic.
you loud and clear, and see you also loud and clear.
Fantastic. Great to hear that. So thanks a lot for inviting me, guys. Very, very, very glad to be here. Thank you, Ulrich, for putting together such a fantastic forum with, I would say, a pretty impressive speakers. So very, very, very much looking forward to contribute as well. So I'll do that. I'll have you for the next 30 minutes. I'll try to be brief. Let me start by sharing my screen here. There we go. All right, so hopefully you can see right now my screen. That's correct. And what I'm going to do is just gonna shut down here. There we go, the heater, because I think it's making lots of noise and it's gonna be uncomfortable for you guys.
For a second, I was thinking you were going to get some robots out there, but.
Right. Just making sure you can see my full screen or my presenter screen right now.
I can see your full screen.
Okay, great. Thank you so much. So hi, everyone. Hope you're having a nice afternoon or morning, wherever you are. So my name is Victor, as Ulrich very nicely presented. I come from a company called Alias Robotics. We are focused in robot cybersecurity. And this speech will shortly speak about how we are currently protecting robot endpoints against cyber threats. Alias Robotics, for those of you that don't know about us, is a Spanish startup founded about 2 years ago, focused on robot cybersecurity and built upon previous experiences in robotics. We've got about a decade of experience in the field. The last 6 years, we've been working in industry real actively, serving robotic solutions, helping customers develop system integration across different robotic domains, from ground vehicles to aerial ones. We've been doing lots of modularity and system integration in industry, complying with different norms and standards. And finally, about 2 years ago, as I pointed out, started building up the blocks of Alias, which, as far as we know, is one of the leading groups trying to push security into robotics as fast and as good as possible. Here are some of the projects we've been involved in, some of the companies we're working with. You can see here some big names in robotics, from manufacturers to software component providers, also hardware component providers, and finally, big telecommunication companies we're starting to engage with, which are very concerned about the current status and use of robots in industry using these mobile cellular networks. Here's another of our customers in the Basque Country, the north of Spain. This customer is producing metal springs, which are used in healthcare and automotive applications, pretty sensitive, I'd say. And over here, you can see actually our solution, the robot immune system, a smart antivirus for robots installed directly into the robot. The robot immune system monitors the interaction of the robot with its environment, learns over time about its activity and adapts accordingly to make sure that whatever happens stays under these secure perimeters and secure mechanisms we set up. As probably most of the previous speakers already highlighted, and some even mentioned, security should hardly or should not be considered a product that you just install and go. It's a process. It's one that needs to be continuously over and over assessed across the different phases. In robotics, these phases are pretty distinct often, and often the case, what happens in development is significantly different from what happens in deployment, production, and post-production. This is our experience. So definitely highlighting the fact that they need to be connected, connecting with this DevSecOps trend, which we hope to bring also to robotics increasingly. We've been working really hard over this period of time. Only this year, we managed to archive, classify, and get together more than 1,000 vulnerabilities for robots. Out of these 1,000, more than 1,000 actually, a quarter, about a bit more than 250, we have released publicly and made them available in a GitHub repository called the Robot Vulnerability Database. And this is, again, available for everyone interested and willing to jump into research, contribute, I hope, as well. We're very thankful to all of the organizations which are listed below, which have been supporting us in this effort for trying to evangelize about and against security by obscurity and try to be a bit more transparent, sharing a bit more of how disclosures should happen in robotics, especially responsive ones, and also to interact with manufacturers, something we've done pretty actively. By doing this, by being so active in security research, as of now, we've served 20 different companies where we are helping to secure robots, and often there's quite a few robots per each one of these companies, so pretty exciting. Now, if we're speaking about cybersecurity in robotics, we need to we need to understand the robotics stack. What are the tools? What are the elements that are used to build robots? It's often the case that we find environments like this one, especially in academia, but increasingly also in service robots, by the way, but increasingly also being translated into industrial applications. Just the last few days, together with Ulrich and other colleagues in the robot cybersecurity community, we've been participating in the ROS Industrial Conference, where it was pretty clear that there's an increasing amount of use of ROS in industry. Even the biggest players are starting to get committed towards it. We had ABB presenting a driver. So I think having ABB shows the level of relevance that ROS is starting to take overall. And as you can see, ROS is highlighted in the middle of this robotics stack. It's widely used across roboticists all around the world. Of course, having ROS is just not enough, and protecting ROS is by far not enough. One needs to understand exactly that there are many other components surrounding it, both at the application level as well as underlying layers. Layer 3 and 4 of the OSI stack are precisely quite important, and getting ourselves aware of that becomes as simple as just analyzing a bit better the computational graph of ROS, the model and the APIs. And for those of you that are not very familiar with this, I encourage you to read that article over there from Bernard Diver, one of our speakers and hosts. This is a fantastic article which explains some of the flaws of ROS really nice, with a pretty nice, I would say, way of explaining it. But long story short, this computational model is composed of different kinds of interactions using different protocols across the different entities that are abstracted in the ROS computational model. And each one of these protocols differs from each other, uses a different, essentially, way of interacting. And as I pointed out, needs to be individually considered, which leads us to easily realize and conclude that securing the robotics stack, securing ROS and its surrounding layers, requires an end-to-end effort. And this is something that historically we've been evangelizing towards it, and now it's starting to be acknowledged. We had to fight quite a bit against this. The way we've been fighting was by ensuring that we could show a real use cases, real POCs of things that could possibly go wrong in a ROS environment. And what we did is we crafted dissectors and package crafters targeting especially these ROS communication primitives, particularly ROS TCP or TCP ROS, UDP ROS, XML RPC on top of HTTP, which is also widely used in the masters and parameters APIs of ROS. So all of that, we crafted it, and we started using it to evaluate the possible things that could go wrong in basically the OSI stack from layer 3 up to layer 7. So we started building up POCs. The first one that I'm going to show you is actually going to exploit a vulnerability at the application layer. Particularly, it's exploiting a vulnerability in XML RPC, which allows all versions of ROS prior to Jade to essentially get disrupted and shut down. In fact, what you'll see is that a malicious attacker is going to craft a package, is going to send it to the master by making a simple request. And this can be as simple as just fetching a parameter. So using the get parameter function of the ROS master API. And this package would have essentially a bomb that would explode in the master by essentially having to send back a significant amount of packages, which eventually bring it down. Again, all versions prior to Jade are affected by this, and this is a vulnerability that we have seen in machines out there available in the cloud. So something pretty concerning, and something definitely that requires a bit more of push from us in the ROS community. This is another vulnerability that uses functionality that we, however, see as a vulnerability. This functionality is a non-documented capability within the master API, which, as its name indicates, it's basically to shut down the master. So that means from any of the ROS essentially nodes. If you're not familiar with this, essentially these are elements that essentially capture computations of the ROS computational graph. So from any of these computations, you're able to bring down the whole ROS network, the whole complete computational robotics graph. And this is because you're calling this function, which again is exposed across all versions of ROS, and there might be very good reasons to maintain this, but if not blocked or protected appropriately, this can be used to bring down servers basically in an ad hoc manner. This last example is presenting a POC that's attacking actually layers 3 and 4, particularly more tackling 4. And to be more specific, it's leveraging the fact that ROS is not using sessions appropriately, which allows an attacker to essentially disrupt an ongoing communication between a listener and a talker. And as you can see in the slide, to bring down the average rate of publication significantly, actually as much as he or she wants, just by understanding the interaction between these two endpoints, and again, crafting packages that exploit the lack of session in here. These are just 3 of the many examples we have with their associated vulnerabilities and mitigations internally within this more than 1,000 we have cooked only this year. And at this point, you might be wondering, well, this is great from a research perspective, but how far does this translate to the real world? Well, this image was just taken a few days ago. This is a robot that's currently right now working and running, that's exposed to the internet, that is using ROS, and particularly ROS Kinetic, for those of you curious about it, that includes a host-based firewall, and that yet is exploitable according to some of the vulnerabilities I've just shown you. So this means we can pretty much compromise the robotic system by simply exploiting some of these flaws, which, by the way, were previously known. None of what I've seen, none of what I'm shown, sorry, are actually zero-based. These are well-known vulnerabilities. Of course, this is a great use case, which is organizing trash. So by no means anyone is encouraged to mess with this, please. But it's just a use case, or more than a use case. It's more an example of how things are currently being done. And something that should change, definitely. And that's what Elias has been doing for the last couple of years. We didn't just wanted to bring you guys today a few examples of vulnerabilities and real systems working out there. We also wanted to give you an intuition of how things are running in ROS right now, in the ROS world. So what we did is we went out there and we started searching for versions of ROS deployed in the cloud. And we found that about 20%, which you have remarked over there in green, about 20% are versions that are end of life. And this might be not really surprising to some of you in the OT environment, working actively, seeing pretty much everyday systems that are not supported anymore. But this in robotics is something that's starting to happen, at least in the ROS community, and something that unfortunately it looks like it will continue. The second biggest chunk we found were machines running ROS Kinetic. About more than half of them are running ROS Kinetic. And unfortunately, ROS Kinetic is going to go end of life in a few days, well, actually a few months, but still not really long time. And unlikely that most of these will move into more modern versions. So definitely a big problem, one we were committed to try to solve. which is the reason why we introduced really recently in our version 2.2.2 of the robot immune system support for ROS kinetic and ROS melodic. We're very proud to essentially be bringing our robot immune system capabilities to these two versions of ROS. Now, those of you that are hearing now for the first time about the robot immune system might be wondering, well, what the hell is this, right? So the robot immune system is our core product. It's essentially an endpoint protection platform meant for robot endpoints, but also meant to protect essentially ROS as well as one of the key components of the robotics ecosystem. Effectively speaking, RIS deploys 5 different modules, which can be actually separated and deployed based on the needs. The first module deploys an adaptive firewall based on our capabilities, based on dissectors that we develop internally. We're able to understand the logic of ROS. We're able to essentially capture these interactions, and by doing this, we can do adaptive firewalling, which allows us to protect the perimeters a bit better than with static firewalls, which, as I showed you in the previous example, are not really effective. Then we deploy a hardening module, which essentially implements the mitigations we identify for all these vulnerabilities we have located. This hardening module essentially is specific to each ROS version or each robot. We then have forensics logging module, which what it does is effectively just records everything that happens within the robot and between the robot and their interactions through its sensors or actuators, and essentially makes it available for posterior analysis if required, something that, well, it's pretty handy when something goes wrong with a robot. The last 2 bits are pretty straightforward. We serve a visualization module, which essentially allows people to introspect the security of ROS. Hi, Francesco. Good to see you.
Hi, sorry.
No worries. The security of ROS can be introspected literally in the ROS computational graph. Our visualization gets embedded into the computational graph, which we think is the right thing to do, especially for remote monitoring and remote assessment of ROS systems. And finally, our artificial immune system module, what we do here is actually not very fancy. We just use some very, very simple machine learning techniques, which allow us to generalize and generate protections beyond exactly what we've seen, exactly what we know is wrong. These very simple machine learning techniques allow us to do this, again, very, very simple stuff, but pretty useful. Having heard all of this, you might be wondering, so if I'm using ROS, if I'm one of these ROS users out there, even in industry, then I can just protect it and I'm fine with this, right? Well, not really. The reason behind this is because, once again, ROS is surrounded by a number of technologies, and more particularly is because all of this is, at the end of the day, embedded into an endpoint, into a robot, one that interacts with its environment, with its environment, and one that can compromise actually the safety of its environment itself. And this is actually one of the big arguments we are using to claim that robot endpoints need to be secured and that robots need to be secured at the endpoint level. Network monitoring solutions, which are widely deployed in ICS and OT environments, are necessary, very much required, but should be complemented with robot endpoint security solutions. Further digging into this, and I think this was touched by previous speakers pretty nicely, is that in robotics, a robot is only safe if secure. Not just in robotics, but particularly for what concerns me as a roboticist, this is true. In other words, safety requirements in robotic standards spawn from security research, cybersecurity research, such as the one I just showed you in the past. And this is not just claimed by ourselves or many other entities increasingly. Actually, this is claimed by the main baseline norms that are being used to build up new safety and security standards. It was widely mentioned before, the IC 62443. I will touch into this and what we are doing about it in just a bit. But there are 2 other norms that are acknowledging this. The first one is the meta standard for functional safety. Some of you might be familiar with it, the 62508. And this one already mentions that essentially if a hazard analysis identifies possible cybersecurity threats, then a complete threat model should be conducted. And if as part of this threat modeling, essentially some aspects are identified, then periodic vulnerability analysis should happen. This is currently not happening with many manufacturers. This is something that should happen and something that the European Machinery Directive is going to impose. You can see a star over there because we're not really sure what's going to be its serial number just yet. It hasn't been released officially, the European Machinery Directive, but it's going to be released very soon. There are a few drafts available, and these ones, at least the latest ones I have reviewed, mention that cybersecurity will be considered a pre-requirement, which I think makes or should make us pretty happy because it's being finally acknowledged. It's going to be in the European Machinery Directive, and this is going to force many of these safety standards to adapt, to consider cybersecurity, and highly likely to point to IEC 62443, which we think is the right thing to do, by the way. Now, beyond this, let's say, theoretical and legal reasons, our team wasn't happy with that. We wanted to dig a bit deeper. So over the past 2 years, we've been generating actually experimental validations, experimental demonstrators that further confirm this. You can see here some of the most popular best-selling robots in Europe for industrial use cases. And in every single one of these, we have been able to develop POCs, which have been essentially developed in-house and definitely not disclosed, that allowed us to compromise these robots, deploying ransomware in all of them remotely, being able to do remote code execution in most of the cases, being able to compromise the safety of the systems. You can see there where we have compromised the safety and the robot is crashing against obstacles, or even worse, in some cases, in the manipulators cases, we've even been able to demonstrate how the robot can literally collide with itself, which is very impressive and very expensive to make because you can only make it once. Now, this is the current reality of industrial robots in Europe. And we were definitely committed to try to offer a solution for this as well, especially with our experience and past work in robot endpoints. So we started speaking with end customers and possible partners. We spoke with lots of possible customers here in the past that were using already security solutions and learned that most of these were monitoring the network. They were IDS, and there are very good reasons why this is like this. In OT environments, in no way I mean to criticize this, and this is definitely the right security choice. However, in the case of robots that interact with the environment, the lack of proactive security mechanisms means that they can compromise this, the safety of these environments and can literally cause human harm. So in our case, we were very committed towards trying to go one step further. Also in these security environments, we essentially analyzed in industry, we identified that perimeters were pretty much static and that changing this was a pretty much big fight with the shop floor owners. This generates a bit of collision with some of the abstractions and assumptions of ROS and another robotics technology. In particular, host-based firewalls that are proposed to secure ROS machines are a bit in conflict with this clearly, with the static perimeters because of the way ROS abstractions work and how power cycling a ROS machine essentially makes the ROS nodes to essentially spawn in arbitrary ports, which well makes things a bit crafty, and you need to understand a bit better the protocol to do things right. Endpoints are really not covered in most of the OT solutions we inspected. And life cycles were just mind-blowing compared to other industries, especially the IT one. Finally, most of the security environments we could analyze and could manage to see were actually secured in a Castellan mode model manner. Which meant that any insider threats were actually not considered. And if a robot goes rogue, rogue, sorry, well, it's clearly a huge flaw that needs to be mitigated. So we started reaching out our network. We spoke with quite a few security companies. We failed to engage a few of the biggest ones. And finally, we managed to find the right partner for these first pilots, and that was Kaspersky. We're pretty happy about our partnership with them so far. And our partnership was all about ensuring that we could deliver a joint solution that protected robots, and a solution that extended their Kaspersky industrial cybersecurity solution with communication, with interaction with our robot immune system living at the endpoint level. That means you can secure now also your robots, you can keep your OT environment secure, and you can manage the security of these endpoints also from these centralized console management solutions that typically ICS solutions include. That is the case of Kaspersky's. Now, RIS is available for ROS, but it's also available for robot endpoints, especially after all this pitch, ensuring we share our concern about the safety. As of today, we have support for more than 46 robot endpoints with some of the top brands in Europe and in the world. We're pretty proud about this. You've got here a short video, You've got here a short video that shows some of these capabilities, essentially demonstrated here in KUKA robot, the visualization, the hardening, the forensic logging, and many more. I encourage you to check our website where these and many more videos are available. I won't bother you with this right now, but I'll tell you a few bits that I think might get your interest regarding what's next for Alias Robotics. Right now, as I pointed out, we're serving more than 46 different robots, and we're serving an increasing amount of customers. We're very excited about our growth. First future bit is that we are in the process of security certifying the robot immune system across different of our supported robot endpoints and technologies. Particularly, we're aiming for the IEC 62443 part 4, 2, and within the security levels available, we're aiming for security level 1 first. I think we were being overly ambitious and tackling security level 2. At least that's what our internal technical effort is about, is still going on. But then after some interactions with some European bodies, we realized that maybe we were shooting too high. So thank you very much for those entities, several of them actually, and actually some of them are involved in this conference. So thanks. Guys, for that, we're now going to tackle security level 1, and we expect to have this in 2021, hopefully very soon. The next thing we're working on is ROS 2 security. Pretty much everyone's speaking in the ROS community about ROS 2, whether I should start using it or stick with ROS 1. I won't tackle that. I can tell you we've been evangelizing for ROS 2 for a very long time. We think ROS 2 is ready for the show. However, ROS 2 is no panacea for security. And those of you that think that ROS 2 solves all your security problems, we are sorry, but that's not the case. ROS 2 security is still very immature, in our opinion, especially because the security of ROS 2 is building on top of the underlying layers, particularly the DDS security plugins are still on a very early phase. Regarding the maturity of the protocol, the specification, and also the implementations are rather recent. So lots of testing is required there. By saying this, I mean that there's still work to do. However, there are some really great community efforts that are already happening. For example, one project I'm particularly very excited about, and I must say kudos for that, is SROS 2, which is a project brought up by essentially cooperators and led by Mikael, which I think will be speaking really soon, probably today or tomorrow. This project essentially builds on top of these security layers at the DDS level, which means that if there's a flaw at the DDS level, then unfortunately, this SROS 2 will need to consider that or suffer from it. SROS 2 is amazing, and I very much encourage all of you to contribute to SROS 2 if you want to get engaged with the ROS community. Mikael is the right person to contact. He'll tell you where you can help and where your help is best required. To finalize with this, I wanted to share for those still skeptical that as of now, the amount of vulnerabilities, particularly 0 days, we have collected and recorded in our database for ROS2 is higher than for ROS1. And actually the severity in some cases is as high. So something to be concerned. And if you're still convinced that you should work with ROS2, which you should definitely for many reasons, real-time and embedded reasons are some of those, we're definitely in good shape to start helping you. So reach us out and we'll do our best. Finalizing on my end, 2 last bits. The first one is we are super excited to have partnered with Telefónica. Telefónica is one of the biggest telecommunication companies in the world, serving hundreds of thousands and millions of users around the world. Basically, they have a big commitment with robotics. They are very interested in the near future of these technologies and the mobile networks that they offer. They want them to be secure for essentially being able to make these robots capable to communicate and to exchange information. So we've partnered with them and we are launching the first robot cybersecurity lab in Germany, Munich. This is gonna happen Q1 to 2021. So very excited about this. If you're interested in 5G robotics and cybersecurity, then partner with us, let us know. There's definitely room for cooperations in here. The last bit is this new project, which we have some announcement to make, hopefully really soon, but I'm giving you a heads up. This project is gonna be about robot honeypots. We're going to deploy hundreds of real, or at least apparently real robots out there in the cloud connected to the internet. Amongst these robots, you will see ROS2 machines, you will see industrial robots that have been virtualized. And as pointed out, we've been working really hard to make sure that they are essentially as close as possible to the real robot so that it's very hard for attackers to notice. And by doing this, we hope to monitor interaction with robots. We hope to learn a lot about how attackers are essentially challenging the security of robots, and with this, make our robot immune system more secure. That's all from my end. I hope you enjoyed and very, very happy to take questions if there are any. Thank you.
Thank you, Victor, for this impressive and interesting updates from ADAS, and congratulations with all of the nice work done. And also from, of course, the contribution, the work together with Telefónica. We'll be definitely excited to host the next Cybersecurity for Robotics conference in the test center in Munich next year. That's so I have decided. But no, we'll have to talk, of course, about that together with Tom as well. Maybe Tom has already organized lots of things to host us in Boston. So, anyways, we might make it a double one. No, great work. I think there was one question from Nicole Dalton, who was asking, Victor, do you have current products or plans for products that work with ROS2? So my gut feeling is that Nicole has one or a couple of projects working on ROS2.
Pretty good question. Thank you for asking. The answer is yes. As I pointed out, we are researching very actively ROS2. One of my past slides was showing you exactly the status and trying to share some awareness. Right now, we don't have a version we can serve you for RIS with ROS2. However, we'll have one very, very soon. What we have right now is a beta version, one that we can share and you can pilot with us. We're very open towards that. We're actually very interested in getting early, essentially early user intuition of our security system for ROS2. So definitely interested in further speaking about this, and let's get in touch. Let's see what we can do together. We're looking into releasing RIS for ROS2 into 2021. I'm very excited to hear that you may have projects running ROS2. This is definitely encouraged, and very much looking forward to see how we can help. Okay,
no further questions, I think, for the time being from the attendees. A question from my end to get a bit of the full perspective here. So you showed the RIS in action. Does it have to be, where do you install it? Is it installed in this case on a separate system? And do you use the basically the network interactions to monitor, or how does it work in practice?
Right. So no, RIS gets installed directly into the robot. It lives inside of the robot. It's a robot endpoint protection platform. Thereby, it is directly adapted to the requirements, capabilities, and specifications of the robot itself. That means sometimes we need to do a bit of, let's say, reverse engineering to make sure we put the pieces together so that it doesn't conflict with the robot operation itself. Every single one of our deployments of RIS is widely tested. And that means that by living inside of the robot, it's able to capture absolutely all of the bits of the robot, meaning network interaction, but also internal aspects of sensing and actuation, which allows us specifically to protect the robot against attacks that may compromise safety, that may compromise further aspects that may eventually lead to robots causing safety hazards, which is our biggest concern right now.
Okay. Thank you very much, Victor, for your presentation and contribution here. For the sake of time, we'll have to move on because there are still quite a number of other topics and questions that I wanted to ask, but I think we'll need to move on. We're running a bit behind schedule now. So Jonas has been around also already for some time, and actually he had also put out a question. And while you're getting on the stage here, Jonas, maybe a final question for you, Victor. If you have had any experience with WireGuard already as a VPN for robots and IoT devices, and how it acts in the real life. I can say that we are doing some experiments with them, with WireGuard, and I have not yet experienced any major flaws or issues, especially since, basically it's known that OpenVPN has quite a number of issues. So we quickly moved away from OpenVPN to WireGuard, and for the time being, it seems to be working quite okay. We didn't have that many disconnects in any case, and it seems to reconnect also automatically quite easily. But Jonas, handing over the floor to you.
Okay, thank you for the invitation and organizing this cross-Atlantic conference. I enjoyed really the talk so far, and now try to share my screen with you.
And Victor, the question was out, so park it if you we can come back to it later.
Sure.
Okay.
I can tackle it, I guess, real quick. And the answer is, so far we haven't seen any customer in our surrounding areas and where we are serving that uses WireGuard. We're somewhat familiar with it. We have seen, however, customers with VPNs, and well, maybe surprising or maybe not, their life cycles that included updating them, which seems to be pretty common for what we are seeing in ICS and OT environments. So we're a bit concerned that many people believe that VPNs are kind of like a silver bullet, and frankly speaking, they are not, and certainly they won't in robotics.
So far with Wireshark, I found that it was very interesting that it's usable on embedded devices because it has very low hardware requirements. And I think this could be very promising in the area of robots and IoT.
Yeah. So definitely to be investigated also what impact it has on the device. But thank you very much for joining in, Jonas. And thanks also for sharing some thoughts with you. As we agreed, I'm going to pause the recording right now.
Okay, thank you.
At least people have seen that something is going to happen, so they'll need to be live for the next time. So in any case, you have done quite a lot of investigative research as well on this cross domain of cybersecurity and safety. And please share with us your thoughts and views.
Yes, one first disclaimer, I'm not a lawyer. I will discuss about topics which are very controversial discussed at the moment. And I suggest that everyone who has to produce products which are used in the area of safety, get legal advice from your lawyer who will help you when bad things happen. This will help you a lot later. I want to explain in a short words which institution I'm coming from. In Germany, we have this special German social accident insurance. And this means that every employer has to pay some contribution for the prevention services and also the compensation if some employer gets injured at work. And the Berufsgenossenschaften, or the German Social Accident Insurance, invest this money to improve the safety at work. And here we are looking on the three pillars. We are providing support for occupational diseases. The insurance covers also commuting accidents. And now we are here on topic, the occupational accidents. So if a robot will injure a person at work, then we will pay for the best possible medical help for the person. And of course, this can be very expensive, and everybody is interested that this does not happen ever. And this is why we are researching and we are helping to improve the safety and security of this technology. The domain of the Institute for Occupational Safety, where I'm working, was for a long time the functional safety. And functional safety reduces the risk of machines. Typical examples are pressure-sensitive mats, or light curtains, or laser scanners. You can see such a light curtain on the right side. There are many small lasers, and if you move the hand through this light curtain, the machine will instantly stop, for example. And now we saw a very critical report in 2019, which I think was very prominent by Trend Micro Research, who investigated industrial crane systems and found out that with a simple software-defined radio, it was trivial to access the control of the crane, and it was even possible to control the crane while the emergency stop was activated. And this is very important in the area of occupational safety because it can instantly kill or hurt people. So our to-do list is we need always security if there's a safety electronic which is used in a network or remote controlled. We have a very important law here. We heard about it in talks earlier, the Machinery Directive in European area, and it defines the legal requirements on machines in the European Economic Area. It defines also what machines are, and robots are clearly machines. And the good thing also for people outside of the European Union is it's translated in 20 languages, so you can learn a lot from it. And you can also use it just as a resource to translate your text or to learn new things about this topic. It's available for free in spite of most standards. I had a lot of discussions with small companies who struggled to afford the money for 14 volumes of the security standard. And this is downloadable for free. And every company with just a few members can afford it. I want to cite a few very interesting parts which could be interesting for everyone who's working on robots or remote controlled industry components. In the Annex 1, we will find one sentence: by the iterative process of risk assessment and the risk reduction referred to above, the manufacturer or his authorized representative shall determine the limits of the machinery, which includes intended use and any reasonable foreseeable misuse thereof. And there we can point out three important things. The one thing which is very often misunderstood is that there is an iterative process. Very often I monitor that companies produce and develop the new flagship project till the end, and then suddenly they see that there's no security, and then they want to heal it afterwards, but this fails usually, and this is not necessary. You should start it right from the first day, and then it should grow in an iterative process. The next thing is that you have always to define the limits of the machine. And the limit is not only geometrical, but also logical. This means if you put the machine in a network, your machine can grow. And also, if you have a radio-controlled machine, it very likely grows. And now there's a very exciting question: what is foreseeable misuse? And we will put a spotlight on this one. There is in the Mechanical Directive 1.1.1i a section: reasonable foreseeable misuse means the use of machinery in a way not intended in the instructions for use, but which may result from readily predictable human behavior. And it's very controversially discussed. The one team says it is foreseeable that the controller will be exposed to attacks in the network. Attacks are part of the network. It's part of a kind of environment. Simply talking, if you know the IP rating, for example, in wet conditions, something like IP65, it's kind of environment protection. And security measures are required, says Team A. And Team B would say the law covers only foreseeable misuse by the user. Criminal acts are not covered. So no action is needed for now. And now we can see what another directive from the EU says here. And there's a link to the foreseeable misuse and the guidance on cybersecurity for medical devices. And this one is very, very clear about this term. And they say the general assumption is that any vulnerability which is deemed to be exploitable for a given implementation of software might be discovered and exploited over time, and as such should be regarded as an enabler for reasonable foreseeable misuse. And here we see that in 2019, we can be very sure that the guys in Europe meant with foreseeable misuse also security attacks. So now let's have a look at standards. I don't know if you know this comic by XKCD. It describes a situation. We also saw that there are many standards for security. And the situation was there are some standards and people say, well, we do not need so many. We need one standard which covers everything. And yes, then we have one standard more. And so the situation how it goes on. But I want to emphasize on some standards, which I think could be very interesting if you want to produce robots in European area and probably also worldwide. At first, very important is the ISO 12100. Here you will find the workflow and all safety basics. Next, it is very interesting to have a look at the 61508, which is written in 7 volumes, and it is very clear about how to produce the electronics and how to write the software. It is very sophisticated. It is close to a construction plan. You can look up how things are done well, and you will find reliability numbers which you can put into your calculations how reliable your controller will be after using these methods. Then you will find the ISO 13849, which is written in 2 volumes. And this is very special because it's not limited to a technology. While the 61508 is limited to electronic devices, which are controllers running a software, we have in the 13849 no technology binding. You can use it for pneumatics, for hydraulics, for mechanics. It's usable for nearly everything. And this is very interesting. If you have a robot which uses a pneumatic actor, then you can also combine the two standards. And if you want to get a quick introduction into these standards and want to have a safe start when reading and applying them, then you can strictly separate the safety and security technology. And this makes the certification afterwards a lot easier. We do a certification in our house, and often I see that the companies do a big mistake by merging standard routines into the safety module. And this is a big problem. And I want to suggest to keep things simple and only put the most important safety-related things in the yellow module, which is safety-related, and all the network stuff and everything else in the standard module, and do not make any interconnections. The trap of security standards is often criticized that the manufacturer has an economic view on the situation. He wants to perform minimal requirements of the standard to fulfill our requirements and will release it very soon. And the attacker looks just up what the standard did not cover, looks up to what security level or whatever the product was certified, and can attack the product successfully at first try, because he knows nobody will invest more time than absolutely necessary, because nobody will pay for it. This is one problem of the standards. One of the most famous standards, we already heard about it, is the IEC 62443, which is very promising. At the moment, we have 13 parts and 5 are still missing. And in our institute, we prepared a test principle, and we are able to test and certify products which are components in the area of functional safety up to security level 1. Well, security level 1 means restrict use of industrial automation and control system according to specified privilege to protect against casual or coincidental misuse, which is, well, it's nearly nothing, you would say. But we saw that it's really hard for most companies to perform this. And the step from security level 1 to security level 2 is so large that most companies have a better advice to perform level 1 first. And if they perform it, then look to level 2. I want to give an example here from our practical research. We see here the entropy analysis of a firmware binary. And we have zero knowledge about the software inside. It's closed source. We just have the binary, and we use the tool END. And we see on the epsilon axis the entropy, and on the on the x-axis we see the bits. And now we can clearly see where the header is. Low entropy shows text or headers, and average, let's say about 4 to 5 to 6, this binary data. And we immediately see the secret key where the maximum entropy is. It's above 7. And there we can use a command to cut out these bytes and directly have the secret key from a binary. And we didn't know anything about the firmware before. And this can be done by anyone. We do not have to know anything special. And we learn from this, cryptography in standard hardware is extremely error-prone and difficult. And I suggest do not reinvent the wheel and rely on verifiable and validated components. So I want to come to my summary. To develop a safe and secure robot, first, start with the security concept at the first day. And you can follow the ISO 12100. And there you'll find a risk assessment flowchart, which is basically recycled in any other standard again. So you do not waste any time if you have a look at this. Never work through a standard as to-do list and stop at the minimum. This will backfire. And minimize and insulate safety-related parts from the standard parts. Thank you very much. I'm looking forward to your questions.
Thank you very much, Jonas. Yeah, there was a little bit of a pause because I was searching for the unmute button here. Bernard, you're there as well somewhere. Did you have any follow-up questions for Jonas?
Yeah, so this is surely very, very interesting also to see it from the side of the insurance. So I think a very obvious question, at least to me, is since you are basically insuring the people using robots, so what would your standpoint be on today's jurisdiction as a basis using today's jurisdiction? If something happens to a worker and you can say it's due to a cyber attack, what would be the standpoint of the insurance in this case?
Well, at first, the insurance would investigate the situation and find out that there was probably an attack. And then the question is, who's responsible for this? The insurance will, in any case, pay all the money beforehand, but will probably get the money back from the employer, probably from the manufacturer. I think both are in the boat at the same time, because the employer has in Germany very clear tasks what to do, and he has to provide a safe workplace. And the law is so strict that you have barely any chance to do riskful things at work. And everybody will say, if you use a robot and put the robot in a network and someone is killed, everybody knows that in the internet, you have to know that there are attacks, that there are hackers on the way, and it is dangerous. And nobody will believe you if you say, oh, I couldn't know this. So the employer will be always in a difficult situation. And probably also the manufacturer, because he has the competence, he has all the knowledge, technology background. And then the question will be, did probably the manufacturer know this before and perhaps hide this information? Or did he document everything responsible in a responsible way? Did he inform other customers? It could be problematic if you know about a backdoor or a problem and hide this information. But we do not have a lot of statistical data about this. This didn't happen very often in the past time. So I cannot make a clear answer. It's just what I would expect. And at the moment, I do not remember of any case where persons were hurt. But the problem is that up to now, we didn't get this information. And we are building up a new network where we will get the information immediately. If a company is attacked in Germany, the BSI will be informed if there is a big thing about it. Let's say it's a critical infrastructure, a power plant or something, they must be informed. But if nothing bad happens and it's just a small company and the robot played a bit around, but nobody was killed, then nobody will look at it, even if it would be possible to kill someone. But in future, the things will change, and we are building up a network together with everybody who's involved. And I think what we also need is something like RAPEX from the EU, where we have a quick conversation between the manufacturer and the user. If there is a vulnerability, that everybody is informed. We also have the CVE meter, but it's too technical and too complicated for the user to find out that some CVE is linked to his robot. Okay.
Yeah, that's quite interesting, because last year at the CSfR, I presented an exploit that we had found in one mobile platform, that you could basically remotely disable the whole safety subsystem. So you basically could just open up the PLC program and rewrite it on the fly. So if, fortunately, this seems to be taken care of 1.5 years later by the manufacturers. At least that's what they said to me, because of course we reported that first and they ignored it for over a year. So in that time when they, of course, did know because we notified them, pretty much they would be responsible from your side of you.
Yes, it depends on the certification, for example, also. Our institute also certifies components. We are notified body, for example, and if your company has a robot and it's certified with the standard 13489, then you have a problem with the software. You are legally forced to provide the information that there's a problem, that there's a vulnerability, and you have to make an announcement. And this is in the contract, and you cannot avoid this. And this is, as far as I know, with every test institute will have this in the contract. That if there's a problem, you have immediately to inform the test institute. There's no time which you can wait. And then you can discuss about the time when you have to release a patch. But the information must be immediately.
Okay, that's highly interesting. Ulrich, shall we postpone further questions until after the next talk? Because I think it will also apply to our next speaker.
Yes, indeed. And that was actually just going to be my proposal here as well, is to get a bit of the perspective from one of those manufacturers. And Francesco, thanks a lot for joining in as well. I assume that this talk was also of interest to you, at least somehow. If you have any reflections on what Jonas has been mentioning, also from your experience already by now for quite a number of years in this space, that would of course be more than useful. Before doing so, I'm going to push a couple of buttons here because we've been a bit out of the air, and we can continue now being on air. So Francesco Ferro, thank you very much for joining in. Francesco is the CEO of Robotics, one of the great innovative companies in Europe, which is producing their own robots, typically humanoid robots, but also being used quite often in the industry, and actually I think even more and more. Isn't it so, Francesco?
You're right.
So why don't you take it a go and share with us some of your views in terms of the safety and security as you see fit.
Okay, so I can try to present. I don't know how to present here. Share screen. Yes. Okay, easy.
The big button, share screen.
Yes. Okay, are you able to see my screen?
Yes, I am. Perfect.
Okay, so I will just try to go fast and don't annoy you with all the company things, but I will try to give our vision about what could be the cybersecurity in a collaborative robotics industry. Okay, like Robotics is touching not only the hardware, but also we have a lot of expertise in the software and also in some of the application in different sectors. And just to have a clear view, we have different business units where you can see that there are different needs from security and safety point of view. Okay, these are the robots that probably you know better than us, and we made a lot of beautiful things. But now just let me share a couple of words about the different business units and the different needs that we have. Starting from social robotics. This is the new robot that we are now launched last year, just before COVID. That is a social robot that is called ARI, that is artificial robot intelligence. And the idea of this robot is an achievable and also not so expensive robot that could be used in an indoor environment to guide people and interact from social point of view. Like you can read there, that is hospital, institution, and also airport, and all these big space. From this point of view, we will also talk later about it probably, but there's still a lot of certification that are quite unclear. So this is one of the problem at the moment. From intralogistic point of view, is more industrial scenario. And from an industrial point of view, the industry part, I have also to add the healthcare, because we are working, for example, with a delivery robots, and also with the COVID, we had also a very good project here in Barcelona with the different hospitals, and also to deliver food and also delivery different materials inside the hospital part. And we are now checking all the certification that are needed in order to do this. So the idea is not to make operation with robots in the sense that we just have interaction, you know, with the patients, but it's just to provide them some tools or some things that they need. And so from retail, we are doing just right now a lot of effort, because probably you know, but we have the Stockbot project. We have different big retailers that are already using, and they have some of our robots in the field, in their shop. For example, for Decathlon, there are in Singapore a shop that is open 24 hours, and all the problems that I just listened in the last presentation, because I was not there for all the workshop, are something that are touching us at some moment, okay? And sometimes insurance helps, other times it's just question of certification, and also to provide the right answer about which kind of risk assessment, and also the solution that you could have. And some of the most important, probably safety from robot point of view, is also intrinsic in the design. So when you design this kind of robots. Another thing is about the product for research. Product for research is just research environment. So you need the CE marking stuff, and not so more certification, because we have to take into account that from certification point of view, usually you certify the solution, and so the use case, and not the robot itself. Okay, this is one of the important points. And one complication, for example, that we are having with the Tiago, because it's very modular from hardware and also software point of view, is also the customization. So how to certify something that is so customizable. So depending on the sector, depend on the field, you have to certify the application that you are doing with your robots. Because imagine if you just change the end effector, and instead to have a gripper, you have a knife, there's no provider or manufacturer all around the world that you just certify that this is so secure. What is important to do is to just have the proper certification from a cyber attack point of view, so from outside. And this is another point. Now, speaking a little bit more about the robotic standards, probably you know, but these are a no exhaustive list about the most important standard in robotics in order to make this kind of safety regulation, okay, that is here. And for example, for the device, the last one, the 13482 is one of the important part for the care personal robots, and that is for the collaborative robots. Also, there's the others that you can see here. About the ISO standardization, there are a lot of things. This is an old image because they also changed now the TC of robotics, and so it's not the last version of this picture, but there are several working groups that are working on the ISO all the time. And then just focusing on cybersecurity point of view is these slides, I think that I also presented in the ERF in Malaga this year, is also a quite good, let me say, ISO collection about the cybersecurity. And you can see here the different points from the technical and technology information, from the industrial network and And here there's also some very good point to discuss probably later. Now speaking about collaborative projects, we are very active. We are participating with a lot of projects. At the moment, we have around 15 projects actively, and I will just speak about a couple of them. Even if I know that Reda, that is also here, he just made a proper explanation about the Sequoia project just a few hours ago. The Cyber Factory one. The Cyber Factory is to use the robot in industrial environments. And so we have different pilots. And the idea is really approach on intralogistic business units that I just presented before, and is to have the proper certification in industrial environments in order to certify this kind of robots. And from cybersecurity point of view, what I can say to you is that most of companies that we are providing at the moment, they just ask to don't be connected to Wi-Fi. So the robots has to have the proper, let me say, software in order to make the task without any connection in the cloud. So in this way, you just cut off a lot of problem about the cybersecurity, but not all. Because, for example, for the mobile base, someone can approach the robot, put a pen drive inside, or just connect to the platform and try to hack or change the code or this kind of. But in an industrial environment, this is a little bit more controlled environment, and so it's not a so big issue, and is not anymore a provider, and so manufacturing point of view, if where you are using the robots, there's this kind of physical attack to the platform. Okay, so this is one of the big important part. And now I speak about the Sequoia project, just our point of view, and the things that we will do with the Airbus and Naval Group in particular, and there are the pilot that we will work with Reda also, in order to make this kind of things properly. And so we are working with the Thiago, and the idea is quite simple, and this is the goal is to ensure this kind of digital transition also in the manufacturing industry. And so the flexibility, the connection, and the automated production is a good challenge, and that's to be found the right trade-off in order to have a user-driven application, but with the proper cybersecurity stuff. About the project, there's an improving coordination about the safety and security teams, and so they are working quite hard in order to have this kind of let me say part well safe, okay, but it's not a finished project, so we are still working on it, and also there's a quite big effort in order to find and adapt the regulatory framework in order to enforcing also the law. And like I said before about pilots is in aerospace and maritime industry, and this is more or less an architecture that we are just thinking, but I think that Reda already spoke about the project properly and probably 10 times better than me. But this is the 3 different levels that we just had, and this is just a big overview of the projects. And probably I just want to mention the human-machine behavior that is one of the important part that we are also aware with the other business unit that I mentioned before, and the idea is just to detect as soon as possible all the deviation of the normal behavior in order to secure this kind of collaboration with human and machine. This is the important part. And this affected the security and the safety for sure. And in order to give more time for a lot of questions that I'm sure that you will have, I want to just to make the conclusion, and the important part is that the safety and the security are the critical points, and are not only for the customers but also for the provider. Probably the security is more for the provider and the safety for the customer, but both are very important for the two parties. And one of the important message, like also I listened in the last presentation from Jonas, is that we have to work with the expert from the beginning in order to have the proper lawyer certification, companies, and etc., in order to make it robust and sure, respecting the law. And so now, if you have any question.
Well, thank you very much for that, Francesco. Well, yeah, I think you gave a very interesting perspective as well. I think properly as we would have expected as a manufacturer, pointing also to some of the challenges and the dues and diligences that you have to deliver, of course, in your environment. But I think there's been some points that might not relate completely in the same level, or that might be a bit diverse from what Jonas has been mentioning. So, of course, you take it from the perspective of as a manufacturer, you're trying to abide by the different regulations, and you have this great perspective. So, which means that there's many different things that you are required to follow. You also mentioned at the very beginning of this afternoon, when we were talking with EU Robotics and Mass Robotics about the challenges in relation also to the systems integrator, because of course you develop basically a device, and then it has to be further integrated and accustomed to where the final situation would need to be. And we also talked a bit about some concepts of shared responsibility, where there was a bit of reluctance from the two major organizations bringing together the manufacturers and having a broader perspective. I mentioned the concept of the security bill of materials, and there was a bit of reluctance from the side of the cybersecurity domain, and also from the in the same play field from the standards organization developments, Jim, that is. So I think there's plenty of work here, and it's going to be very difficult to maintain it as a complete level. I think what you're trying to do rightfully is trying to protect your business and your company from basically malicious abuse, that people are using it in a way that it's not intended to be used, and therefore it's going to be maybe resulting in an adverse effect that might return to you. So you try to get your lawyers in time, as you say, to prevent any potential liabilities. But still, I'm thinking, isn't there another way to do this? I mean, isn't there a more cooperative way? You rightfully point out here at the very end, okay, include from in the beginning the experts, as in terms of the lawyers and the certification people. But what about the experts from the cybersecurity domain? So isn't there a mechanism or a way that we would be able to include much earlier on also cybersecurity thinking in your design processes, especially when you're saying, okay, many of our robots are modular. So you start with one, you build basically on top, and also the software basically has to be in a similar way. So I'm trying to explore a bit and to sense out how we, and I'm now talking basically to you as sort of the representative also from the manufacturer's domain, how that could improve, let's put it this way, gently.
Okay, it's a very, very broad question, because it really depends, you know, it's really, the generic answer will be that it really depends on the project, in the sense that from one side, you have the machine that you have to build and try to ensure the cyber security as much as you can. And but from the other side, the most important part is to ensure the use case. And so it depends. This is my point of view, because we are working with different companies, and it's not the same. For example, Decathlon that I mentioned before, with a very industrial and old, let me say, industrial company that are producing other kind of things in another sector. Okay.
Yeah.
So it really depends on the use case, and
we
based on
agree.
the use case. Yeah,
we totally agree from that point. So we have what we call a holistic approach in terms of cybersecurity. So we start from the enterprise and from the business risk. So without a doubt.
Yeah.
So and then indeed the use case depends.
Yeah. So depending on the use case, but this is the generic answer. Okay, like I said before. Then going in the specific, how we can improve this kind of let me say cybersecurity. From one side is to having someone developing and taking the compliance and all these issues inside company, and this person is not me, so this has to be clear. Okay. So I'm not the expert at this moment of the cybersecurity in the company, but I have a couple of people that are working on this subject. Okay. And from the other side, having also some training of this person with the proper companies, and depending on the use case, why not working with some of them? So at the moment, a part of some European projects or some proposal that we did with some we say expert company and cybersecurity, we are not actively working massively in another private projects, but I think that is something that will start soon. Okay, and the idea is not to make the similar error that everybody is doing in robotics. That okay, I build this platform, is very good, and now use it, but it's going to the use case, demonstrate the use case, and improve it as much as possible with the proper experts. Okay, so from one side, the development has to be safe, okay, in order to don't have any big issue. Okay, so it's the material also that you mentioned, the build the materials to be at the beginning in the design, and then about the more software related part, in my opinion, we can improve a lot. And also I just listened to the Victor that he was mentioned that also ROS 2, that it looked like that, like is wow, it will be the best. It have a lot of issue about also the security part. So there's a lot of space for a lot of improvements.
Jonas, Bernard, do you have any questions, comments?
Yeah. So I would like to get a general view also from you, Francesco, and then maybe an afterwards comment also from Jonas and maybe everyone else of the panel who is still here. So if we're really having a new legislation, like a new machinery directive that will actually ask for cybersecurity aspects, and also the 10 to 18 will most probably have that in there next year. How well prepared are manufacturers for that? What would be your opinion? So what will be happen? Will it be the golden age of security consultants, or is there actually something happening at the manufacturer side already?
Yeah, I think, Jonas, please go.
I think in theory they are well prepared because the requirements are very old, and it's nothing. In practical viewing, they are not very well prepared, and they have often a very bad structure because they mix the safety and the standard components together, and it's not trivial to insulate them ever. And you want to update all the standard components often, where you have interaction with the client, with the API, with some network services. There you need often updates and changes. And if you change the safety-related components, you have to recertify the whole product, which is very expensive and requires a lot of time. And if you find that in the past, an old release had a vulnerability which can cause an accident and can hurt people, then you have to make an announcement and get this product from the market. And this is very, very, very expensive. And you want to avoid this for any price.
If I can add something, because also the question it was if it will be a lot of work for the companies that providing this kind of help and expertise of subject security. I will say that at the beginning for sure, and then depending on the project in this way, I think that will be more and more emphasis on that. So for sure, the cybersecurity is now taking more and more seriously into account, and the law and regulation usually will make a big stop. But then the real use case, and this is my opinion, because I know a lot of directors that have a company and a factory and whatever, and they would like to completely follow the rules all the time, but sometimes they have to take some kind of risk, especially, for example, for the collaborative robotics and everything. There are still a lot of interpretation, let me say in this way, or you can also say this, adapting the regulation in order to avoid the typical mistake, and at the same time make it safe for people, because the safety is one important issue. But it's true that the regulation at the moment that they have to follow, we have to follow, are not so strict in this sense. So in my opinion, this will happen, and the regulation of the next year, hopefully next year, will help a lot in order to make the things properly.
What we also think about, or should think about as a cybersecurity community for robotics, also I think should be to address the integrators, because we saw that in the statistics, the integrators are by far the largest part of people working in this field, and I think they are the least prepared, at least in my experience. So talking to them about cybersecurity is often harder than talking to the manufacturers.
I think it sometimes differs a bit, Bernard, in that space. Not all of them are equal. What we do see is a number of traditional OT operators and integrators, as I can call them, where there's indeed not that much cybersecurity attitudes part of their day-to-day operation, because indeed they don't know anything about it, and they're also in the learning process. What you do have is quite a number of system integrators which are combining the two worlds already, and then it becomes much more of interest. But then what we typically see is that from the customer side, there's a sort of a reluctance because it increases the budget of the systems integration to an effect that it's not really acceptable anymore. So it basically adds to the whole project. So that brings us back to the point whereby we need to also make sure that cybersecurity is part of the standard equipment being provided. Now, what I've heard earlier this week as well is that there is a new machine directive in the making, where I think I've heard that is expected to land somewhere end of next year, probably somewhere mid 2022. Maybe Jonas and Francesco, you have also an idea about this. From my end, I'm coming from the world whereby I have seen much more developments towards certification of devices. And so then I'm talking about ENISA, I'm talking about Cybersecurity Act, and I'm talking about cybersecurity certification of basically all devices which will be equipped with any form of connectivity. And so there is now a lot of work being done whereby the radio equipment directive, which is also being upgraded, is being considered there to serve as a sort of a baseline. So you see that there's actually many different things are joining in, but from many different domains and different spaces. And the most, the one that I see most in terms of cybersecurity is definitely the one from ENISA, from the CyberSecurity Act. So I haven't looked into that, how that affects the machine directive or the upcoming machine directive. So if any of you has a better view on this, then I would definitely be interested to hear. But coming back to another point in this discussion is really, where do we put the responsibilities, and is there a way that we can say, okay, yes, it is a form of shared responsibility, and yes, maybe we need to put some sort of a baseline here that says that every development of a product, including basically in this case a robot, has to have a very baseline level of cybersecurity components in there that we can basically agree upon, and that's basically the type of interaction that we really would like to have with the manufacturer community.
Yes, I think this is also so. Also, the 62443 prescribes exactly that, because there you have the manufacturer, you have the integrator, and you have the end user, and every one of those has specific responsibilities that they have to take care about. So I think it won't work otherwise.
Reda, you're raising your hand here in the panel.
Yeah, I had a question because I'm not very familiar with the initiative in terms of cybersecurity of robotics, and I was wondering whether there is a kind of maturity model that people need to refer to, and if that case, whether we can consider to have a kind of different degrees of trustworthiness that we can associate with different robots, because I believe that in the near future we will have coexistence of different robots and coming from different manufacturers, and not all of them belong to let's say lands of laws, and with different practice and compliance with regulation and respect to European and maybe transatlantic regulations. I believe that people working on a kind of metrics to evaluate the degree of trustworthiness of robots, and in compliance with the model, I think it could be something that might help people around. I'm also surprised that ENISA doesn't have good practice report dedicated as we do for automotive or IoT, dedicated for robotic. I think there is an action there to create a working group. I've been in one of these expert group. I think it's a good idea to push towards having this kind of, let's say, grouping activity with manufacturer experts from one domain. So it's two question, recommendation, I don't know, but I'll let you reply.
Yeah. Francesco, any perspective from your side there?
I'm not a magician, so I don't know exactly what will happen, but in my opinion, I agree a lot with the word of Bernard, that we need to help the system integrator, because from one side we have to produce robots, so we in some way we have the proper expert that is helping us, or the lawyer, whatever. But then I've seen a kind of jungle from a system integrator point of view, that you made some robots, like for example the software part of Tiago or the Tiago base, that are quite safe, that then just add some modules on some other part that completely destroy all the the security that you put there. So sometimes I've seen some not proper use of this. So we needed to from one side to help the integrator in order to make that this kind of things will not happen. And at the end of the day, also from the legal point of view, when you are speaking about the use case, the final integrator has the most of the responsibility about what will happen with the machine. So from one side, the producer that produced the machine and the software, whatever, but then if he touch and has the possibility to touch the things, he has the liability of what it happens in the use case. and sometimes they will not have even the strength to have a proper expert about the cybersecurity in particular. Okay, so I agree that we need to have a kind of evangelization, I don't know how to call it. And then from the other side, I know some tools that could help in this sense. For example, there are some middleware that could help. For example, from ROS, there is the ROS industrial community that just made a workshop a couple of days ago that try to also face front some of these issues. Okay, not all, but is at least a good beginning. And then there are other initiatives, like, for example, the Romosis system, that is another middleware that helping in robotics, this kind of behavior. And but it's still, in my opinion, very gray side, in the sense that we need to make more than that.
Yeah, I think those points are definitely also very valid. So I think, I mean, we're taking small steps here, which is, I guess, in any case, a good thing, because I think there are steps towards a direction whereby we're all benefiting from in the end. And that's basically, number one, acknowledging that there is something that needs to be done. Secondly, it's an approach whereby we also all see that it doesn't have to come from one entity by itself, but it's actually a combination of different entities where it has to come from. So we don't expect from the manufacturers that they do everything, that you have basically 15 cybersecurity experts in-house to only focus on this. I think it really is a combination of pointing to the same way as we have done on safety, that it needs to point towards cybersecurity, because those two go hand in hand. And it has to be, in any case, a collaboration, which is weighted, and whereby, at least on the integrator side and the customer side, there's also the acceptance that this is has to be handled. So it takes me actually to one of the talks tomorrow. I mentioned it already. One of the system integrators, which has been deploying robots, and was called in by one of their customers, basically because they had a cybersecurity incident that caused a safety issue with one of their employees. And also another one which was hijacked basically for cryptocurrency. So those things do happen. We see them popping up more and more often. The fact that we have researchers like Bernard and Victor and many others that are trying to understand what the vulnerabilities are of the robot systems also helps out, providing much more transparency and insights also where some of the challenges are coming from, that at least also we know how to handle them. Unfortunately, what we don't have is neither magicians. And I think, however, Francesco, when I look at you, you do have a little bit the looks of a magician. So after this life, you could basically go into another life and become a magician. I'm certain you will do a great job there. But beyond that, I don't think that in the world of, if you start talking again, then we can see that. Say something, Francesco, and show again the picture, because people don't see it.
Okay, I can speak a little bit if you want. You know, I'm Italian. I can speak forever if you want. But I just show you some robots over there. No?
It looks like a series of white Christmas trees.
Yes, at the moment we are preparing a video with more than 14 robots, adding robots.
Ah,
okay.
Cool.
Yeah.
Okay.
So yeah.
Let's stay tuned. Then.
Yeah.
But to finalize my point, I don't think that you have to expect either from the cybersecurity domain that we're going to basically be able to resolve everything with just another tool or a piece of components and technologies. It doesn't work that way. I think the different components like RIS from Alias Robotics, the vulnerability disclosure database, the tooling from projects such as Sequoia, where you have different security operating centers working together on a shared intelligence platform. All of those things have to be integrated and have to basically come up with the total solution. fundamentally, I think what we need to get to work to is using platforms like this to really do the interactions, and hopefully also to get much more of both integrators, end users, and manufacturers and cybersecurity people on board to discuss. So with this, we reached the deadline of 18:30 or 12:30 US time. Tom, I see that you're still alive. How is it going?
It's good. I really enjoyed the discussions. I think that our focus a little bit on the third-party integrators is interesting, but we need to realize that is only a small portion of the deployed robots. We're going to have a lot of systems that will have no third-party integrator. Francisco talked about they're doing elder care, and you can imagine that they're going to be consumer applications where there is no expert, and these will be put on their home network. They will have a whole host of sensors that can gather an incredible amount of information about that home, and it will be widely available. So we've got to look at the whole host of robots, and but I love the discussions that we've been having today.
Very good point. And tomorrow we'll be also showing a domestic robot that has been hacked by the same people that basically hacked my Tesla. But that's for tomorrow. So with this, I would like to thank a lot all of you as speakers, Francesco, Bernard, Tom, Reda, Jonas. You're still here. And then, of course, the other ones that already left by now. So Bernard and Tom, I'll be seeing you tomorrow, definitely. And maybe Reda, Jonas, and Francesco as well. So please do join in. Thanks a lot in any case for your contributions and insightful comments. And hopefully we can continue the discussion in live debates next year in a face-to-face setting. But definitely also just continue the discussions.
Thanks a lot for organizing, Ulrich. It's such a great event again.
Yes, thank you very much.
Right.
We have to continue in this way.
Super. And see you tomorrow. 12
see you tomorrow.
2 o'clock in Central European time, and that's 8 a.m. Is it in the US, East Coast?
Okay.
Bye now.
Bye.
Bye.
Goodbye.